Yeah, dear members, good afternoon to all. On behalf of IFSR and Chennai chapter, it's my pleasure to welcome you all for today's technical program on the topic Zero Maintenance Approach Part 2. So last month we had Part 1 and it is a continuous webinar. So this month it is a Part 2. And we are honored to have Mr. S.Sundaresan, Senior Vice President, Operation and Technical from Breaks India on the session and as our keynote speaker for today's event. The program has been organized by IIF Chennai chapter and IFSR with the aim of discussing the latest advancement and innovation in the field of zero maintenance approach. This topic is of a great importance in today's fast-packed world where time is valuable commodity and maintenance cost can be a sufficient significant burden on the companies. Mr. Sundaresan is renowned expert in this field, and we are confident that his insight and experience will provide valuable learning opportunity for all members. We hope that this program will serve as a platform for networking and knowledge sharing among the participants. On, on behalf of IFSR and Chennai chapter, I extend a warm welcome to all the attendees and we look forward to a fruitful and engaged program. Thank you.
Thank
Sundaresan
you.
sir, thank you, sir.
Thank you, Mr. Muthukumar. Thank you,
Yeah.
Vignesh,
Thank
for
you,
the brief
Chairman. So
introduction.
before
And
we request all the members to please kindly mute your microphone, sir, because this will be a very interactive session, but we will want to have it at the end of the session, all the questions and anything to be asked. So requesting you all to please mute your microphones and also please switch off your cameras because it will be a kind of a disturbance in the side. So only the speaker and his presentation should be on the screen, sir. So requesting you all to please abide by that. And as Muthukumar sir said, this is the 40th program which is being organized by Chennai chapter, and this is a
fine. Good afternoon, gentlemen. So
Good afternoon, sir.
we had seen the part 1 program of the zero breakdown maintenance approach last month, and I suppose all of you, those who were present for the first program, are now present for this second part of the program, which I would try to complete by this time. Also, there had been few queries with regard to the air management system from one of the participants, Mr. Shanmugam from Madras Engineering. And I'm also now trying to include the air management system, what has been followed here in Breaks India Foundry. Before me start continuing my talk from the previous meeting, so I would just rush upon those notes which we had seen during the first half of the session, means the last month, to just brush up so that the continuity of the program which will be much useful for those. And people, those who are joined now for the second program, they might have some opportunity to go through this, based on which they can able to build a platform for the forthcoming slides. So I had discussed about the maintenance objectives. The first and foremost being to sustain the zero breakdown. Please note the word sustain the zero breakdown. It is not the question of achieving 1 month and then trying to have some breakdowns or some failures in the forthcoming months. Once you achieve breakdown, zero breakdown, you shall be in a position to sustain that by various practices, which I had discussed during the previous month. And also we'll just brush upon those points and support quality maintenance to minimize the defects, which we did discuss about the Q parts. And we talked about the increasing the mean time between failures and reduce the mean time to repair. The higher the mean time between failures, the better the maintenance management system is. And the lower the mean time to repair, the better the maintenance management system is. To upgrade the process and equipment knowledge, I was explaining you about owning your own car, managing your own car, based on which the onus on the maintenance and the management is lying with the owner, means the person who operates the particular machine. So we should come with a my own machine, I own machine, and it is my machine concept, based on which we can able to equip on the equipment front and also optimize the consumption of spare parts and minimizing the maintenance cost, which we will discuss during this period. I have also touched upon what deterioration is all about, which can be either natural deterioration or forced or accelerated deterioration. And the natural, we need to take how we need to measure the natural deterioration based on the time-based or condition-based. And accelerated deterioration can be touched upon by looking at the abnormalities, what one we see on day-to-day operations, and then take your corrective actions over the abnormalities. And also I was explaining about the preventive maintenance. It is like a health check what one patient undergoes. Normally, the scenario is that everyone need to go for a body health check on an annual basis so as to ensure the wellness of the health. It is not for the illness people do visit hospital. The scenario is now changed. Earlier days, people they visit hospitals only for the illness, and now the scenario is that so many programs are there based on which the wellness of the person is being diagnosed, based on which you can able to be living happily. So the health checkups, which talks about the health prevention, daily prevention, which talks about the daily maintenance like lubrication, cleaning, inspection, without any tools associated with you. You need to use only your 5 senses for understanding the abnormalities. Health checkups, diagnosis is inspection diagnosis, and early treatment in the medical field like preventive maintenance and repairs, which also include advanced replacements. This is what I was correlating maintenance of the machines with the health of the people.
Hello.
Yes, please.
Sir, requesting members to please not disturb the thing, sir.
Okay, I continue.
Sir, please go ahead, sir.
Yeah. See, on the maintenance management system, I was talking about. I request the rest of the members, please mute your microphone so that the class can go without any interruptions. The end of which I leave the stage open for questions. I did talk about supporting the autonomous maintenance. Autonomous maintenance is the maintenance that is being carried out to the person who operates. Jishu Hosen in Japanese term, you call that, where the abnormality corrections, abnormality first, finding out the abnormality, managing an abnormality register, and putting a red tag that this is an area of abnormality, like seeing with 5 senses whether any air leakages which you feel, whether any oil leakages you see, whether there any overheating again you feel, whether there is any odor then which you smell. So with that you can able to find out that there is something going abnormal than what it used to be ever. So based on which you put a tag and then mark the abnormalities and then take corrective actions to ensure the abnormalities are being taken off. So you need to again teach the Jishuosan team to ensure the abnormality corrections are also being taken care. On the preventive maintenance, I did speak about inspection repair, where people they need to go around the entire equipment and see, and they need to do the inspection where there is any looseness or any adjustments requirement and all that. Again, this gets recorded through the abnormalities and need to assess whether the abnormality can wait until the weekend shutdown or month-end shutdown, upon which you can plan. If not, it is better that we inform the plant in charge, stop the equipment, carry out the maintenance, and then restart the entire line. That would definitely improve upon improving the maintenance cost. Also, we did discuss about the time-based maintenance, where initially when you find that there are some failures related to a specific area, obviously if it is because of the natural deterioration, you fix up the timeline, like how I was talking about engine oil change. For every 500 hours of operation, every 1000 hours of operation, 800 hours of operation, obviously there is a time-based fixed, whether engine being used, engine is not used. So on this concept, you fix up on the time-based maintenance calendar, by which the maintenance activities are carried out. By following the time-based maintenance calendar, the maintenance cost would still be slightly higher when compared to the condition-based maintenance. But now we are at that stage where we need to follow time-based maintenance so as to achieve zero breakdown concept. Over we acquiring better knowledge, then we can able to assess the condition of the equipment. When I say condition of the equipment, we are going to split up to the spare parts, which I will see the forthcoming slides. You will be able to understand that. So predictive on the condition-based maintenance, obviously the equipment conditions, spare part conditions are being managed or being assessed through a PM analysis, about which also we will discuss. And we also discuss about the predictive maintenance. There are online, offline predictive maintenance methodologies, and I've also explained you various methodologies that are being deployed at Brakes India Foundry division. Then we need to now touch upon the breakdown maintenance and corrective maintenance, about which we'll see during this program. Abnormality corrections, how the abnormality is being perceived, it is judged, and also action, which I've also explained you. This is to be done only with the 5 senses. And you need to find out the improvement methodology to see the hard areas where the access of cleaning is not there, access for better inspection, access for lubrication, retightening, adjustments, and where it is hard, access for the operations. All these the areas are to be looked in, and we need to take corrective actions. These are the examples which I have also explained. I'm going a bit fast because all these points already been covered during the previous month program.
Correct பண்ணேன்.
So
ஆர் போட்டுருந்தீங்க, நான் எடுத்துட்டு என்ன போட்டேன்.
Can you please mute? I request.
Sorry, sir. I've
team
muted
members to please mute. Okay. So these are some of the abnormalities, how these are the corrections are being taken up, which also I explained. And step 4, we did explain about the general equipment inspection. The complete equipment, we need to understand the complete equipment. Only then we can able to find out how it is going to affect our process. Then also I did explain about the process inspection, how on the QA, on the Q components, where it is going to end up with a reject product at the end of the line. So we shall have a complete knowledge about the process and what are going to be the quality related issues that are arising out of these equipments, for which what are the time-based or condition-based maintenance management need to be deployed across the machines. And step 6, standardization. Step 7, issue was an always. Step 7 is the final step where everything is taken into account, including safety, including the complete operations, process, maintenance management, time-based maintenance, condition-based, everything is added together, and you can proudly call this is my machine. So to that stage is a step 7, which I am not explaining here. Everyone who's undergoing this maintenance techniques also need to follow such practices in your own shop floor, and you should be proud enough to say my machine. You should say that I have achieved step 7 in my machine. You can go, you can choose the machines upon the importance or priority in your shop, and accordingly you can plan the calendar in such a way that at one point of time all the machines would be under step 7 concepts. Then we did discuss about the inspection repair, AM/PM checklist sharing. So when I say inspection repair, this is a preventive maintenance checklist, what normally one follow. And when I mean AM is a autonomous maintenance, and when I mean PM, it is a planned maintenance concept. Initially, to start with, as per the JPM, as per the TPM, JIPM procedures, you need to have these 2 groups. Okay, though I made a point that there shall not be any maintenance department, separate department attached to any lines. Always the production and maintenance shall work hand in glove, and it is only the operational person need to carry out the maintenance. To that extent, the technique is to be understood, and the skill has to get inculcated amongst the individuals. So this is what I was talking about. And initially, to start with, obviously need to have a knowledge on what an abnormality means and how I need to know about this, how the machine works, what are the mechanisms by doing the adjustments, what is going to be the end result, what is the process variations which is happening out of the machine. All such things are the step 3, step 4 standards about which I explained. And it will take time for these operational team to understand these concepts, upon which they can proudly come out to the step 7 standards. So when I say the inspection repair, these checkpoints are to be allocated to AM and PM checklist, And initially, those checklists which are being done only with your 5 sensors will be under the AM. Then PM, you need to have an exhaustive, you can even engage some external parties to carry out the PM wherever the facility is not available with the organizations. Okay, so where a detailed analysis need to be undertaken and also a major overhaul when it is taken up, obviously PM would come for the help. So over a period of time, most of the PM checklist should get transferred to the AM. That means obviously there will not be any planned maintenance at all. It is all be undertaken by one maintenance team, which is also a production team, which is a major concept of the TPM terminology. We also touched upon the condition-based maintenance management program, where both online system, offline system was discussed. And I also explained you all this sensor module processing, condition monitoring, all that. We explained again over the temperature sensor current transducer in a motor, where you have a PLC system for signal processing, and you can have a trend where you can able to see the condition monitoring, and the diagnostic module, the supervisory control data acquisition system will be there, based on which you have a reporting system. So I was also explaining about the offline condition-based management program, maintenance management program, thermography, ferrography, vibration analysis, the individual details of which also was seen. These are thermal imaging camera I had explained, and also ferrography, use of electrostatic filtration or a regular filtration as the case may be, so as to extend the life of the lubricating or rather not lubricating oil, but hydraulic oil. Thereby, it also adds another dimensions that the production, that the generation of the hazardous waste also gets minimized by extending the life of the oil. I did explain about the vibration analysis. Using a vibration analyzer, you can do the balancing of the systems, rotary systems. Also, you can able to check upon the foundation or any looseness in the foundation, or any bearing failures can also be attributed. The diagnosis can be done based on the type of the amplitude or the frequency what you get out of the rotating equipment. This is another example which I have shown you with regard to the velocity. And then upon finding out the velocity exceeding, obviously some correction has been taken up, and again ensured that the velocity is within the control level. Also, I did talk about the UT measurement, which extensively Foundry process they will also use. Insulation resistance measurement, capacitance measurement.
Yes, sir.
Can you please mute, please?
Sorry, sir, I have muted him. You can go ahead.
Yeah, it's okay. Yeah. And also, I touched upon the TDS measurement of water. For water, various measurement techniques, which was also discussed. Gate pulse measurement, exclusively used for induction furnaces panel, firing module. And this is also we saw. All these things together and a condition-based we saw. These are all done offline methodology. And also, I did explain about how they are deployed, the various methodology across various machines. Up to this, I think we had completed. Clear? Now we again, in fact, condition-based maintenance management technique, if you come across, obviously that would be the extreme end, where then we'll have to talk only on the physical phenomena analysis. Okay, so I am just again explaining you all whatever that we discussed in one this graph, which talks to you about this graph where the x-axis is a time. Okay, and I was mentioning you the mean time between failure. The higher the mean time between failure, the better the maintenance management system is what I mentioned. And on the y-axis, we have the deterioration, where it can be a natural or a forced deterioration. So when you see this graph, I'll just make the pointer now. Is it the pointer visible? So when you see this, this graph, see, obviously this is the original condition. When I say original condition, again, this is a misnomer. When a new machine is there, obviously the new machine, whatever the conditions, any new machine is there, which we call it an original condition. Okay, and we also call limit conditions. That means up to this limit conditions, we can allow the machines to operate. Then after, we need to take a corrective actions so that we should bring back the machine to the original conditions. We shall never allow the machine to go beyond these limit conditions, which could endanger with a breakdown. So that is what exactly this whole concept and this graph depicts about. So what I am trying to say here, see, this is the forced natural and forced deterioration, which is pulling down the machine parameters to the limiting conditions. Once it comes to these conditions, obviously, when we are taking up the daily JH, like the daily patrolling, which we discussed about, also inspection repair. So based on this, with the daily checks, we can able to bring back the machine to the original conditions. See, when we follow this JIPM, TPM terminology, and we follow such practices in the shop floor, there is no concept of an old machine at all. No one can say that my machine is 10 years old, 20 years old, and accuracy will be that, and all that is total rubbish. Obviously, irrespective of the age of the machine shall be as good as that of a new machine, at least from the functional point of view, at least from the operational point of view, everything should be like a new machine. That should be the concept of a TPM. Nobody can say that this machine is 10 years old and the accuracy is limited and all that. Then obviously it means that the JPM, TPM concepts are not adapted onto this particular machine, is what it means. So when I say original conditions, as good as new machine. By carrying out this particular taking precautions over the forced deteriorations. Whenever foundry industry, again, I also told you during the last program, it's a 3D industry, difficult to work, dirty, dangerous, and all that people say. And I also said it is a myth and nothing is dirty. We can able to improve upon the air ventilation system in such a way that the foundry can be as clean as that of any machine shop. So the working atmosphere also should be more conducive for people to work, so that the machines can also breathe easy. That is more important. Okay. Besides the men working inside the foundry breathing easy, the machines shall also breathe easy to ensure a good environment. So that means I say the forced duration has been removed. That is what I'm trying to say here. And also foundry industry where there is a sand foundry, let us assume. Obviously, people might think there is a sand foundry, there can be sand leakages which will normally happen. So to that extent, we should try to see if it is an abnormal sand leakages. Obviously, we should not be in a position to allow such sand leakages. This will also cause forced deterioration onto those spare parts and cause forced deterioration based, it will cause a breakdown. So taking these corrective actions, providing some better guards for that, and also ensure that this is removed from the area of forced deterioration. And if at all you could not able to change the phenomena of some leakages, then such case being the last what you can do is to protect with some guard so that that does not affect the specific part which goes under breakdown. So by taking such actions, we can able to extend the life. This is carried out through a daily Jishuhosen patrol. Then next is Jishuhosen plus IR plus TBM. When I say IR, this is an inspection repair, which is a contributing factor both to Jishuhosen as well as plant maintenance. JH plus PM is what I said in the IR. So the checklist, when I say IR checklist, part of which will be JH, part of which will be PM. And over a period of acquiring better knowledge, all those checklists, all those checkpoints which are featuring in the PM shall get added onto the JH. Thereby, there is only one checklist based on which the foundry should be able to sustain. And the TBM we talked about time-based maintenance. By adopting these practices, we can further able to increase the MTBF timeline. Now comes TBM. Apart from the TBM, when you do the condition-based maintenance, then further the limiting conditions can be extended further. So by following all these practices, the literal meaning of this graph is that the mean time between failure could be extended to the greatest possible. So there shall never be any breakdown before the machine goes for a next shutdown maintenance, for the weekend shutdown maintenance. So that should be the concept by which we should approach this maintenance management. And I again hear some background noise. I request everybody to mute, please. I request the members to please mute. There is a background noise. Yeah, it is perfect. Thank you. So this is the total which we have seen. Now we are coming into the breakdown. Okay. So the concept or the theme of our class is zero breakdown maintenance. So despite I say zero breakdown maintenance, still we are talking about breakdown. Okay. So we may classify the equipments upon the importance, where it can be classified as a category, B category, C category machines. Okay. So A category machines are those where you should give utmost priority so that the stoppage of such A categories would completely stop the foundry line. So such case being, we are not allowed to go for A category machines breakdown. Okay. When I say C categories, where there is a spare machine available. Let us, as an example, I say, let us take a cooling tower. Okay. Normally a cooling tower, you have one pump associated with that. And also, obviously, there will be a standby pump associated with this running pump. And it would be a regular practice for any industry that you operate both the pumps on a periodical changeover with every week changeover or every 15 days changeover also. So such case being a breakdown of one may not affect the complete line. It will affect, of course, breakdown is a breakdown, no doubt about that, but it is not affecting the complete foundry line. Thereby, you can immediately switch over to the spare equipment, spare machine. Thereby, you can able to attend to this. So, what I am trying to say here is that, of course, if at all a breakdown comes, the first and foremost is to restore the equipment. So that is what it says. Failure restoration is the first and foremost, followed by YY analysis. And I did explain about the YY analysis. Obviously, if anybody who is seeing a breakdown of any equipment, upon restoration of which, if you do a YY analysis, you shall be in a position to go up to 5 Ys. Okay. If you could able to answer 5 Ys, then the analysis is much better. There can be a situation where beyond the third Y, it would be very difficult enough to pinpoint. So the maintenance management techniques, we need to really understand the deeper the subject, the more number of Ys we can still go for. So why I am trying to say this, if you go deeper, more number of Ys, then obviously the root cause will be very crystal clear. And the failure and root cause will be 180 degrees opposite. Once the failure is known, root cause is known. So you take again 180 degrees corrective actions. Obviously, then you could able to ensure that the recurrence of such breakdown would not be there. So that is what I mean by that. Then recurrence prevention, again, the same thing which I explained. When I see, when we study the ideal conditions of the equipment, so again, foundry, there will be so many equipments from a molding line, further conveyors, and then shakeout. There will be a cooling drum, then so many list of bucket elevators, conveyors, or magnetic separators, furnaces, cooling towers, pumps, cranes, so on and so forth. So when you say so many equipments, every equipment, if you take individual equipments, when we adapt this zero breakdown maintenance concept, obviously first you should choose master machines. Okay, those machines which are worst in relation to the number of breakdowns, in relation to the MTBF, in relation to the maintenance cost, in relation to how it affects the production line. So such worst 5 machines are to be taken as a model machines. Okay, see the model machine concept, why I say, once you work upon such model machines, once you deploy all such techniques into this model machine, the result of which, if you see, if you make model machine as a zero breakdown machines, obviously the entire plant will be watching you, how you are working onto the model machine. So the interest, see, when I take model machine, obviously there will be a limited team who will be working onto the model machine, adapting all the maintenance practices which I had explained. Okay, where those such facilities are not available in the foundry, they should be in a position to get such facilities outsourced and then try to adapt, so that they could able to definitely see a breakdown, zero breakdown concepts in those model machines. Only upon seeing the zero breakdown being achieved in those model machines, that would give a definite good breath among the rest of the team members upon seeing that. And now you can start taking more number of machines, and groups can be allocated in such a way that 50% of those machines can be taken up for the zero breakdown machine concept. So once you attain that, then you can further increase the machine population. Thereby, whole plant will come under this scrutiny over a period of years. Okay, it might take definitely years, like how the child birth from walking to the running, what I had explained. It will take years for those who are practicing from the scratch. So this is what maybe the equipment. Equipment, when you see the equipment, it is the total process conditions, operating conditions, usage conditions, whether it is meeting the specifications is what we need to really understand. And then we should also see the installation accuracy of this equipments as a total equipment when you see. Then when you come into this assembly part, obviously assemblies and sub-assemblies are part of those equipments, where viewing from this assembly level, you should be in a position to see whether this vibrations, backlash systems, and then the linkage, appropriateness of the fittings and all that with regard to the assembly accuracies. And functional part, you should be able to see, you should be able to understand whether sustainability of parts, state of the operation, system reliability are in place. And environment, I already explained to you enough on this 3D dust heat cleaning methodology. When we again break this sub-assembly parts into final parts, spare parts, viewing at this level, the appearance and shape, whether there is abnormalities in this particular part, where there is a rust, where there is any decolorizations, wear out, all such things. Dimensional accuracy, like the machine pin I explained during the previous meeting, the required accuracy of the machine pin, diametric pin, roughness, finish, and then service life, cleaning methodology, all such things can also be seen. So what I am trying to emphasize the fact here is that people should be in a position to understand from the spare parts, from the final part, okay, where the accuracy level, where they wear out, all such things, they should be in a position to understand this. When we are doing Y-way analysis, I explained to you the three way up to 3Y people will be doing it. If you go for more number of Ys, up to 5Y, if you are able to do, then your understanding is much better. There is also another methodology in JAPM, TPM system on the physical phenomenal analysis, PM analysis they call it. So in the PM analysis, whenever there is, we are now talking about breakdown restoration. Once machine is restored, we are talking about analysis why breakdown has happened. Okay, so on to this analysis, now we are talking up to the spare parts level, just to refresh. When we come to the spare parts level and assembly level, when you go for the PM analysis, you will have to write down what is the chronic problem, because the problem may not be repeating on a daily basis, but you might be seeing this problem very regularly without any answers to that. Is what which demands the PM analysis is to be definitely taken to understand what is this chronic problem, how this need to be attached, how needs it to be taken care. So let us take a problem. In our case, let us say if there is any mold leakage, let us assume so. Okay, so when you pour the metal, again when the mold is continuously moving on to the AMC, automatic mold conveyor, you end up with a mold leakage. Okay, and suddenly it happens the 100th mold, suddenly it happens in 1000th mold. Okay, let us assume so, and it is not continuous, and maybe
sir,
once in.
Sundaresan sir.
Yes, please.
Sir, your this thing presentation has gone off. I think somebody else disturbed it.
Ah, okay, okay.
See, Mr. Anantanarayanan is. Yeah, now it is fine, sir.
Now it is fine.
Yeah.
Okay, am I audible?
Yes, sir. Yes, sir. Yes. Sir.
Okay, fine. So I was talking about the PM analysis, where if at all any problem where there is no direct answer for that. Okay, so you need to really list down all those factors. Okay, there can be 100 factors. Okay, so but do not leave any factor unattended. Okay, so list down all those factors. First, write down the problem. The problem statement is there is a mold leakage. That's it. Then all those factors which might be related to the process, which might be related to the equipment, which might be related to the maintenance equipment, rather one not only the equipment, rather the tooling also. Okay, where the correctness of the tooling. So not leaving out anything, and also it may be related to the skill level of the people, understanding and knowledge level of the people with regard to the operations, with regard to the management. Okay, so do not leave any points and then list out all those points. Okay, and we need to really find out the what should be the standard? Okay, that you'll have to tabulate against every point. What is the acceptance criteria or what is acceptable limits? Okay, when I talk about the up to the spare part level or up to the assembly level or up to the final what do you call the functional check? Okay, the functional check, let us assume so. If there is any gearbox, then you need to really see what is a backlash. You can measure that. Similarly, if there is any axial play, you need to measure that. So there will be some acceptance criteria which would be specifically maintained or specifically mentioned in the maintenance manual of those particular equipment. But there will be many items where the acceptance criteria would not have been mentioned in the maintenance manual. So you need to take your own experience, or you can discuss with those people who have been working with the machines for years, and you need to take the acceptance criteria like that. Okay, wherever that measurement had never been done earlier and you do not know what should be the acceptance criteria, at least you take the minimum what it is today. Okay, so that part of it you need to have a standard mentioned against each point. Then you come to the real measurement of the existing spare parts, be it a spare part level. Now I am talking from this particular slide from the spare part level. What is abnormality, whether it is any rusting is there, whether any stains are found, if there any decoloration is there, whether any wear out is there. If at all, you will have to write exact conditions. That is what is called a physical phenomena against the standards. And once there is any deviation against the standards, obviously you need to write OK or NOK. So for 100 those factors, you need to write like this, upon which there can be all factors can be OK. If that is so, obviously the breakdown could not have happened at all. Okay, there could be some factors which are NOK. It can be one factor or it can be a combination of factors, which we do not know at this stage. Okay, so such case being, you need to really attack all those NOK together. That is what the system talk about. If there are 3 NOKs you find when you do this analysis, when you are measuring all these points and then you are writing down the chart against the standards, there is any deviation from the standards. If there are 3 NOKs which you find amongst about 100 points, then the corrective actions that to be taken for all 3 at a time. You shall not be doing it one you do it and then trying to see whether it becomes okay and then I'm taking the corrective action for the second. That should not be the approach when you are following the PM analysis. So while doing the PM analysis, this understanding of the equipment, understanding the assembly, sub-assembly and spare parts level is very, very essential. That is why I am giving more importance for this particular slide. Now, concept for reducing the failures. These are the 7 concepts to realize zero failures. First, we need to do the classification of the failures. Why the failure happened? What are the classifications? Then analysis. I have explained about the analysis. Then preparation of basic conditions. You should remember the step 3 standards of the JH, which I explained. That is the basic conditions. Then observance of the conditions of use, rectification of the deterioration, forced deterioration, of course, and improvement of the design shortcomings, improvement of the operational maintenance skills. Okay, so these are the concepts by which you can able to realize zero failures. When I say combinations, so combinations factors, inadequate basic conditions. Everybody is quite aware now. Basic conditions is the condition at which you need to take actions. That is the limiting conditions which I said. Okay, once a new machine comes, this is the state at which it is there. Okay, then once you operate the machine, there will be a slight deterioration, over which once it goes to limiting conditions, obviously you need to take action about that, either by daily patrol or by daily patrol plus inspection repair, or by daily patrol plus inspection repair plus TBM, or by daily patrol plus inspection repair plus TBM plus CBM. Okay, by which you can able to improve upon the particular factor, particular equipment from the limiting conditions to the basic conditions. So when inadequate basic conditions, there can be some deteriorations, there can be some what do you call a lapse in the ER, lapse in the TBM, which might be combinations for this failure. Lack of skills, as I said earlier, nobody is born Brahma here. Everybody need to learn from the scratch. That is very important. Let us not have any ego. For better understanding, you can definitely approach any individuals who are better equipped and try to understand the concepts from various textbooks. From various YouTubes also we can understand now, because understanding how a differential works in an automobile, it will be a difficult question even for a BE engineer, BE mechanical engineer today. Okay, once you go through YouTube and see how a differential gear works, then obviously it will be very easy. So much of literature, so much of videos available now online, and also you can also you have a lot of expert people amongst your own team, amongst your own factories, where you can have a fruitful discussions with them, try to understand, try to improve upon that. That is enhancing the knowledge of individuals. Once the knowledge is enhanced, obviously such knowledge has to be put into practice. That is what I say skill. The skill level is that only when the knowledge is put into practice, the skill level gets improved. And when I say the skill level gets improved, if you repeatedly keep doing this particular activity in such a way that even while you are deep sleep, you are asked to carry out that work, you could able to do it with 100% perfection. Then we call that he is an expert in this. This is called an expertise. Okay, excellent driver who can just drive at any conditions, even 24 hours. If he could not able to sleep, still you asked to drive. Obviously he can. Only such people are required for driving ambulance. Okay, I'm explaining. So that is what an expertise is. Anybody who's driving are not an expert. Maybe they know. Okay, teaching how to drive is a knowledge, and really driving on the road is a skill. He is putting the knowledge into practice. And an ambulance driver is an expert, obviously. So that is what a basic difference between sharing the knowledge and putting such knowledge into skill and then getting expert onto this field. So that is what the lack of skills. So people should get enhanced with their knowledge and put such things into the operations. Never mind if there is a failure, but you can always back up. Third being the design shortcomings. There can be various areas, even the machine builder himself had not designed the particular requirement. Okay, so they would not have assumed the duty of our operations. So such case being, with this design shortcomings, there could be failures. So we need to have discussions with the machine equipment manufacturers, and we need to improve upon the design with their help. Okay, that is part number one. If they could able to lend their ear properly. Okay, if there is any reluctance from the machine builder saying that his machine is superior and the breakdowns are caused only because of the lack of skill from the user end or inappropriate maintenance from the user end, obviously if you find with your PM analysis it is only because of the design weakness, you can able to improve upon the design yourselves. Okay, why I said first you approach the machine builder, because machine may be under warranty, so you need to have the machine builder support over a period of years. So that is the reason why you always keep the machine equipment manifest also into confidence while taking up the design improvements. Then non-observance of usage conditions, about which we had discussed enough, leaving deterioration unrepaired. Okay, we know that there's a forced deterioration and we should take actions to prevent the forced deterioration. If these are all the various factors which can aid into failures, and combination of the factors also is clearly spelled out. And this slide in fact should precede the earlier one. This is what I discussed earlier, and these are all the factors causing the failure factors, and these are all the concepts by which the factors could be reduced to zero, is what this slide should have been the next slide. Sorry about that. Then program zero failures. So these are the 7 steps I discussed how we need to achieve zero failure. First step being sorting out the past failures. Okay, so we need to see first sorting out the past failures. So what are the activities which I need to take up for sorting out the past failures? The classification of recurring or sudden failures. Okay, classification based on the difficulties, classification based on the occurrence portions, classification based on the failure modes. This is how we need to sort out first. Okay, first 5 years when I sort, the first yes being sort. Okay, so when I sort, then what I should do? There shall be some role for the Jishu Hosan, autonomous maintenance, and there shall be role for PM. PM will do the teaching for JH. You try to understand, PM's role will always be educating the JH. At one point of time, over years, there shall not be no PM, and it is only the JH with the operations or to be the managers or to be the owners of the equipment. So also PM would help in sourcing the external team for major overhauls, external team for conducting the condition-based maintenance techniques where the appropriate equipments are not available in that specific foundries. So such case being, PM can definitely engage themselves in carrying out such things. Okay, whereas all the activities of PM should be done with the knowledge of AM, so that AM over a period of years they get adequate knowledge in those operations as well the maintenance, the safety of the equipment, and also with regard to the process, how the Q components are to be addressed over a period of time. So when I say now sorting out the past failures, the role of the JH is to identify responsibility attributable to the JH regarding the misoperations. Okay, there can be also misoperations based on which the failure can come, and taking steps, education and foolproofing. Okay, when I say foolproofing, it is a okay, what you call that, to ensure that even if I want to make mistakes, the system shall be in such a way that it takes care of that. And how to handle the future failures that can be dealt by Jishu Hosan. Role of PM, as I said, identify the recurring failures based on the maintenance records and perform permanent fixing failures which have been dealt with a quick fix. When I say quick fix, it is not just for the time being. It shall be for in such a way that the activity, the corrective actions, what is taken up, shall ensure that no recurrence should happen. When I say analysis, you do the re-analysis of the recurrent failures, thorough analysis of the new failures. Okay, this also we discussed the YY analysis. We also discussed enough on the physical phenomenon analysis. Role of JH, analyzing the failures, considering that they are problems of the JH. Okay, of course, any failures is the individual failure. People, then only the ownership would come into the picture. Okay, we should feel that as because of our own understanding level or our own inadequate attention given for the correct maintenance, it is our own misoperation of the equipment, this particular failure happened. So such feel if one gets, obviously then he is one who owns it. Okay, then repeating YY analysis, inspection of analogs, facilities, and correction of causes. Role of PM here, thorough analysis and guidance. Okay, when I say thorough analysis, I've also explained about the PM analysis, confirmation, correction of repair errors, skill, education, training, all that is to be undertaken with the JH. So PM role is very important in engaging JH to ensure that they are educated at all levels, right from finding the abnormalities up to carrying out the PM analysis. Elimination of the forced deterioration and rectification of unattended deterioration. So this is step 3. These are all the programs for zero failures. When I say step 3, Jishu Hosan, the role of Jishu Hosan is finding the defect through cleaning. When I say Jishu Hosan, obviously initially when we discussed during the previous program, not to forget that we need to allot time for cleaning the machine, lubricating the machine, and inspecting the machine. Okay, so there could be a question where if I stop the machine for cleaning, lubrication, inspection, whether it would affect my production line, whether it would affect my mold output and all that. Initially, you might have such feeling of stopping the production, and hence it is going to it is going to affect your productivity. But over a period of time, we will be in a position to understand that these minor stoppages would be totally prevented such a way that the total productivity would get enhanced by taking such appropriate measures of cleaning, lubrication, inspection. And I've also shown the photographs earlier where the equipment, to make the equipment as transparent as possible, the equipment manufacturers provide a complete non-transparent opaque doors. Then you make your own cutouts and you make acrylics such a way that the parts which are moving inside are visible to the person who's standing outside, so that the abnormalities can be seen even while the machine is in operation. Okay, so make things more visible. Make the maintenance management, what we need to do, more transparent. That is what the step 3 checklist talks about. Make all the photographs and you write down how it should read, whether it's in green color, whether it is in red color, all such things. If you make more of visual control, then by just looking at it, people can understand whether it is okay, not okay. So to that extent, we should make the machine more visible so that machine can able to speak. This also we discussed within the last meeting. We shall be graduating our level in such a way that we should be able to converse with the machine. Okay, machine is also like a human. It can explain the machine's difficulties, that the machine is being overloaded, and with whom it will cry. It will cry only with the operational person with whom the machine is associated with on an everyday basis. So the operation person shall be in such a way that he could able to see the machine, he can able to see the problem what the machine faces, he could able to hear the cry of the machine and should able to take a corrective action, so that both machine as well the operating person shall be happy enough working together. So that is what I mean by finding defects through cleaning. So you should allot time for the cleaning, make machine clean. When I say machine cleaning, obviously I want the whole foundry to be clean. When I say foundry clean, people they shall see foundry as like a machine shop. To that extent is what one need to expect. Okay, nothing more, nothing beyond, I would say. Then improvement of the basic conditions. We already talked about basic conditions more. Direct sustainable oiling, all such things we discussed. And studying use condition. What is the role of PM here? Again, education. Classification, guidance of use condition, elimination of the force deterioration. Of course, when the operator, he finds that this is an area where the sandfall is there, he does not know how to prevent the sandfall. Wherever the sand is coming from, it may be from other department. Or you can, in a sand plant, if you see the sandfall or a dust can be from other department onto the melting area. So we need to really take the corrective actions the other end. Okay. So these activities PM will educate and try to take a corrective action so that the force deterioration is taken care of. Then fourth point is study of the weak points. This is what I was talking, study of the weak points. It could be related to the machine design weakness by itself from the machine manufacturers, or by our own use, by misuse of the machines, we are getting into the weakness. Okay, there can be two possibilities. So what is the role of JH here? Implementing the improvements such that the maintenance of basic conditions is easier, easy to inspect, easy to lubricate, easy to clean, easy to retighten. Okay, like that. When I say retighten, I don't want the bolt, whatever that I have tightened, does not get loosened once again because of the vibrations. So what I should do, I can make an eye mark. I can make a eye mark onto the bolt along with the base, so that by just looking at the eye mark matching with the base to the bolt. So on a daily basis, when I see, then obviously you come to know that the bolt has not loosened again. So like that, we need to make a more visual controls. Okay. This is with regard to just an example with regard to the retightening. With regard to the lubrication, you shall have a flow meter, you shall have a pressure gauge upon the lubricating oil, all such things where you can bring more into the visual. And if there is any pressure gauge indicating the lubricating pressure or the system pressure, then the operating range can be marked with the green color, and anything which is less than the operating range, which might create a problem, you mark it with a red small sticker onto the gauge. So by just looking at that, the gauge being in the green zone, so one will know that the operating range is okay, the lubrication is okay and all that. Similarly, there can be some areas where there can be a flow meter for the lubrication system, especially in the gearboxes. So where flow meter is there, you bring that flow meter again more with the output of the flow meter shall be made into a digital, so that you can able to see the flow, so many liters per minute. Always you can able to see in the digital system, and also you can further bring into the controls that if it goes beyond, if it is under flow, obviously it gives some siren and then try to give a warning. Okay, so these are the areas by which you can able to improve the countermeasures against the contamination of sources, hard to access areas. Then what is the role of PM in this case? Sorting out, correcting the design weakness points. Okay, so hard to lubricate, then you make in such a way, there can be areas where the bearings are to be removed, lubricated, and that to be refixed. There will not be any holes provided, and there cannot be any grease points also by virtue of some mistake in the design at the OEM. These are all the possibilities which I am trying to say. So such case being, you may have to remove the entire bearing case, you may have to remove the bearing, you may have to drill, you may have to do some grease points, and also extend the grease points through some grease hoses outside, so that even without even opening the door, you can able to do through the hose, you can able to do the greasing. Ensure that the grease point is appropriately fixed in such a way that the bearing gets lubricated. So what I am trying to say, we need to look our own systems. It is not something which we can copy from other people. Okay, because we are owners of our machines. Okay, one machine may not be the same of the other. Okay, so such case being basic concepts you can able to understand from others, but the working of which what is easier for us, it can be even different from one factory to another factory. Whatever the concepts you follow can be little different from the others, but the ultimate aim is that you should make the system in such a way that people can able to inspect the machine very easy, inspects those points which are prone for force deterioration easy, which are prone for difficult to lubricate, you need to make it easy, which are prone difficult for retightening, you should make it easy. So such case being, you are making the corrections against these design weaknesses and also trying to extend the service life of the equipment. And wherever there is any buckling or the whole machine base itself is buckling. So because of inadequate structural supports, obviously we need to go with adequate supports. There can be areas where the bearing they may not be using the appropriate bearing for that particular duty cycle. Then you may have to go for a C3 clearance bearing. You may have to change the bearing type itself. Okay, there are cases where we have changed the bearing type. We have changed the clearance of the bearing in such a way that we could able to prevent the failures. It is not that we did not have failures at all. So many failures we had, and based on the experiences, all such things have been taken up, and finally it gets into the computerized maintenance management system. Then fifth step, preparation and control of standard documents. So again, we discussed the preparation of the standard documents. Initially, upon carrying out, first step is to find out the abnormalities. Second step is taking corrective actions against the abnormalities, which we saw. Third step is the documentation, which is a tentative standard, I said. Tentative standard is likely to get amended. Okay, so what I see today, I make a standard with the pictorial standard I make, so that easy for anybody to understand, more visual control in the equipment. Okay, so this preparation of the JISHU OSIN standard documents is what is this. And I've also told about documentation in the step 6, where it is a detailed documentation. It is not step 3 is only a tentative standards. Step 4 is a complete equipment. If I do not lubricate, what is going to happen? What is the after effect? If I do not do cleaning of this, what is going to the after effect? So all such questions are put forth. Then that becomes more equipment. You get to know more about the equipment. That is step 4 I said. And step 5 we talked about the process, total process. How machine is related to the process. How machine gives the best product, quality product. Okay, that is what the process understanding. Sixth step is a complete documentation I discussed. Okay, so the documentation here, when I say here the step 5, the preparation of JISHU OSIN standard documents, including step 6. Then checklist based on inspection and rectification, IR we talked about. Inspection, correction of malfunctions through total equipment inspection. What is the role of PM here? Preparation of regular maintenance standard documents, again IR checklist. Okay, the IR checklist again being shared between AM, PM, and over a period, again over JH takes up the entire thing. Classification of relations between equipment accuracy and quality characteristics. This is, we talked about step 5, where the equipment accuracy and equipment quality characteristics are determined by those spare parts which are attributable for the quality product coming out of the machine. Efficiency improvement of maintenance. Visual controls, make Foundry visual. I don't say equipment here. Make Foundry as visual as possible. Implementation of predictive maintenance. We did discuss enough about the predictive maintenance during the last program, and I have shared in the, when I started this program, I have shared what are those predictive maintenance online, offline practices that are being deployed. So implementation of predictive maintenance, condition-based monitoring, or simple diagnostic equipment, trend control. I suppose
any further questions?
You are clear.
Mr. Sundaresan?
And end of the session,
You can either unmute yourself and ask the question, or you can put it in the chat box.
I'm not specific
Mr.
to
Ishwar,
single equipment
very
here.
good evening.
And
Fantastic
trying to
presentation,
explain
a very elaborative session.
with,
Is there a standard calculation or a
in DISA I
formula
do, what
to
in
arrive
AXA
the
I do,
manpower
what in
required
the
for a
vibrometer
plant
I do, and all that.
maintenance based on
What in the
machines?
furnace I do. This is an overall. There is no standard maintenance formula management program which I am talking about. You the end of the program, if your shop any specific queries related to the equipments, there are how many machines in your shop discussed. So you list down all those machines later also, and then you list down all those This is the third part because we talked from the very basics, breakdown maintenance. Okay, and so now we list down all the checklist corrective need to be, which is design weakness correction, about which we also discussed because checklist breakdown maintenance. How many people requirement again? We did all the analysis. The analysis, failure analysis can be attributable to we also do not saw various how to deploy by which people failure analysis is attributed either by the maintenance and the production together or by inappropriate maintenance management you need to what is deploy those people for carrying out because to follow machines are calendar now or the checklist or to follow the at least for the time being firm or okay tentative time being firm machine design until so there are 5 factors the checklist let us assume the checklist also happen and the breakdown maintenance once we analysis or PM analysis when we discussed what is the to manpower the recurrence prevention all the obviously shifts we need to also you need to calculate and you can arrive implement so individuals depending upon out of the analysis magnum on which their Foundry plan related to they can derive design weakness but as such we also discussed about how the design weakness formula like taken up either by improving the lubrication or by improving the structural like that or by improving the part by itself. Okay. First, let us try to design weakness correction. Zero breakdown approach taken up. First, that is more maintenance prevention that is the first aim. Improve the MTBF only for which the entire class we talked we have been conducting maintenance and all the data whatever whatever the support you carrying out all these things. Keep doing this. Initially, when you start you yourself will evolve the sense abnormality there and if you could not able to achieve and you do the analysis and also obviously will have ending up with you'll have a knowledge line or ending up with inadequate manpower will maybe also attended to. Such case being because it gives you an indirect idea whether may warrant some is their replacement. So may warrant it is upon our own methodology how we follow this very religiously. So depending upon the availability of our own availability to consumables that shall be because you can't experience this and then arrive at the timing at which obviously correction is to be taken. You can do the planning properly and then you arrive at some depending upon based on which you work abnormality and when you continuously work you need to decide whether plus minus you can able to take up the corrective action over a period of the week or end of the fortnight or which demands immediate attention. Okay, any emergency abnormalities you don't allow the still the machine be in operation. You do not allow the machine to be in operation. Rather, you stop the machine, carry out the abnormality correction. I will be able to provide back in operation so that it would definitely see an improvement on. So you can pass it on because machine failing by itself and attending to that on hiring methodology or also if you want to own it also. If you see the abnormalities, stop the machine, correct the machine. Your R&D can be is what I'm trying. I think my utility team is also present in this all meeting. Data you will get. And by doing the should also be notation patrol and doing equipment wise.
Okay.
So acoustic camera spare which requires time-based control and what periodicity this requires replacement. Okay. And what are those spares which require condition based like wire rope which I said. Okay. Over a period of 1 month you change our crane wire rope. That is a time-based maintenance irrespective of the conditions being okay and okay. My prime aim, the best way is to not have any failure related to the rope. Earlier days, we used to be having our own so such case being TBM, okay, fine. And all that, but it is quite expensive. To start with, I'm fulfilling my bound to get leakage. So that is more important. The best so once I have 1 year nowadays operation with all aluminium pipes become wiser. So I can able to still put my signature saying that this particular rope can even withstand beyond the shrink fit and absolutely zero based on the experience what you see. Lifetime. So you would have understood the concepts of the machine. You would have understood the not so expensive compared to the so then you can able to see what are those failure modes in the wire more because any loose strands you can fit and forget or you can able to check the strands. So such way, if I could able to implement by checking the wire, checking the wire rope on a periodical basis, every day I can able to check, every week I can able to check, I can able to extend the life of the wire rope from 1 year to 1.5 years. That becomes a condition based. So you are now enhancing the replacement period from 1 year to 1.5 years. Thereby,
what are the action need to be taken to reduce also to reach the best level?
Benefited. So that's what I mean to say here. So you get a data. What are those pairs which needs replacement based on the conditions? There are about 10-15 points. I will cover predictive maintenance. At least what are those machines? I also show some examples. The person equipment able to understand various predictive maintenance techniques. So what are the techniques that are going to deploy? Two types of calibration. And how it is deployed? What is the data derived out of that? What is the trend? One is the trend based on the trend. Whether I need to action dynamic calibration. So these are all the data static calibrations. And we talk about in the event of a breakdown, obviously there is some background noise immediate after restoration. You do analysis and you understand it is because of what phenomena and you take corrective actions for that. And the corrective actions can be improving your TBM or
Fine.
improving
Now
your
it's okay.
CBM
Yeah.
or improving your
Static
skill
level
calibration. Okay.
We,
So these things are to be
take
again
the
documented.
PP
So all
and
such
SP. When I say
documents, by
PP, it is a
carrying
pressure
out
plate,
from
and
the
SP is a
first
swing plate.
supporting autonomous
The two
maintenance,
halves
you
where
get
the
so much of
toolings
data
are
to the
mounted,
corrective
the
maintenance.
pins,
All these
the
data
diameter of the
you can
pins,
feed into
the
your own
height of the pins
managed system
with
which you
respect
call
to
it a
the
computer
bottom
management
plate.
system. Somebody was asking
Uh,
whether
this
ready-made
is
computer
to be
management
taken
system
up,
available.
okay, on the machine
Ready-made
front.
available. There are so many people
And
who provides the computer management system ready-made, but
the
you can make your own system in such a way that is adaptable to you.
there is a mold guide
terminology
when
what
the
you
PP
use
travels,
more applicable for you for
on the
easy
bottom plate
understanding.
itself before it
For
goes to
teaching
the
with your
automatic mold
people,
conveyor.
it is more
There will be a mold
easy to
guide.
teach and easy
The
to
wear
adapt.
out of the mold guide
So
is
based
also
on which you
equally
can also
important.
make
Whenever
in such a way
any
system such a
new
way
chamber
that
plates are
it can give
replaced
you
upon
an alert.
the time-based
whenever the time
replacement
is
or condition-based
about to reach.
replacement.
So it will give
The
you an
first
alert
mold
through mail
after the new
saying
chamber
that
plate is
this
made.
particular equipment
The first mold which comes out of that,
so it can give an alert.
you
this engine
loosen
needs a replacement.
the
It can
mold
give an
guides
alert
on either
that,
side, both
the,
left side, right side, and you need
trend
to
of
press
this
the
particular
mold guides
vibration. I see there
exactly
is a
against
improved. There
the
is a
fresh
trend is going
formed new mold
negative way.
and
Obviously,
tighten
this
it.
needs to be looked in.
And you
So
shall
based
use
on such alerts, you
light
can able to take
to see there is no
corrective
light
actions
gap
immediately.
from the top
That
to
is
the
what
bottom,
I mean
so
by
that
computerized
the butting of the
management
mold
system,
gap,
and
mold
it is one
retainer exactly
the individual
butting the mold
organization to need to
without
develop
any air
based
gap.
on those data
So
which
when there is
they
any
derive
undue wear out,
from
you will be
day
able
one.
to see the light
Or from
coming
the
out,
day they
and
start.
that gives you an inference.
So this
that requires
what we have
replacement.
developed within
So
our
this
own
is the first
system
area where the mold comes
we
out.
go for different projects. Okay.
Then it gets
So,
into
whatever
AMC,
the
automatic mold
improvements
conveyor.
which you have done.
The automatic
in,
mold
the
conveyor,
equipments
it is operated
in
through
previous projects.
thrust bars.
So there
on
can
either
be
side.
some design improvements
In
which you
thrust
have done.
bars,
There can
which
be some
presses the
easy to
mold,
maintain
and
improvements
then
which
it
will be done.
transfers the mold
All such
to
things
one pitch,
are documented and we
releases the
call
mold
that maintenance
and comes
prevention
back to the
sheets.
home position.
Okay, this is called an MP
So
sheet.
during this movement,
So the maintenance
this
prevention
thrust bars
sheets becomes
shall
a
be
knowledge
centrally
database
aligned.
equipment
That is very
wise.
important.
Be it a small,
Which
be it a
can be
big,
checked
never mind.
for a
All the things
AMC
gets
alignment.
into our
And
own
thrust
computer
bars
management
are to
system
be
so
checked
that
for
this
free
can be
movement.
used. The maintenance prevention sheet
Sometimes
can be
because of
re-verified
continuous
for
metal
any
pouring
new
and all
projects
that,
you
there
go.
can be a
Obviously,
possibility of
these
the thrust
points will
bars at
become
one end get stuck.
improvement points.
So
in
we shall
the
try
machine
to
discussions.
move the thrust bars by
Or
hand.
when
That's a logic
when you have a new
where you
machines
could
in
able to
place
move it by hand
different
with one
locations,
person.
not the entire
Okay.
plant.
So
Those
that check we need to do.
improvement points
And
related to
the
those
thrust
equipments
bars
can
on
be
either
taken
side
as
shall be
a
centralized.
handy
That adjustment also has to be
literature
checked with
by
a
which you can
thread
able to
running
improve the
in the center of the
maintenance
AMC.
reliability of the equipment.
Once you
This
do
is
all
more
this
on
alignment and
improving the
also
reliability of the
AMC
maintenance
rails
equipments,
on which the
thereby
mold is moving,
the headache of
there
the
can be 3
maintenance guys
segments, there can be
very
4
much
segments.
reduced.
The
These
alignment
are
of the rails
examples
are to be
of
checked with the
the
water
MP
columns.
sheets.
That also is
we
very
have
important.
categorized
That can be
on
done on a
various
monthly
parameters
basis.
like
But all other
productivity
things are
and
to be done
cost,
on a weekly basis.
like quality,
Once
like
you
reliability of the maintenance,
clamp the
all such things.
AMC, there is
Under
no
such
mold. AMC is thoroughly
categories,
cleaned, machine is
we
thoroughly
make so
cleaned,
much of MP
and
sheets.
AMC is clamped.
This is maintenance prevention
So on the
sheets.
clamped condition,
Okay. So
the
how we
maintenance
do all this will be
technician or
documented,
maintenance
and
manager
if you
whomever
click
carrying
the
out the job
individual maintenance
should
prevention
sit
sheet,
on the
you can able to
machine
see
bottom plate,
what is the detail of
and
this.
you should sit
And
means
then
you should lie down.
this can be adapted
and
to
you should
the
see
new
the
projects
thrust
or
bars
the new
exactly
equipment as the
it is
case may
one
be.
plane.
Just an
There
example
shall
of the
not be
MP
any
sheet. This is knowledge
variations
database.
thrust bar from the inlet thrust bar to
Specifications
the
vibro,
outlet
where
thrust
with
bar.
the heaters and liners.
Absolutely, it shall look
Originally,
like
there
a
was no
string
liners.
of a
So we
same
have
line.
incorporated
So this is very
liners,
important
so that the deck of those
mismatch.
equipment was wearing out,
Okay.
and it warrants
So
replacement every
when you
6 years,
carry
7
out
years.
this, these are all called
So we could be
mechanical
able to
adjustments on
incorporate
machine
those
and
liners
AMC
ourselves.
alignments.
Of course, with
By carrying out all this
equipment
methodology, you
manufacturers
can
into confidence.
assure
And
that
then we have
the
incorporated
mismatch
the
can be
heating
well
systems
under control
underneath,
within
so that the sand
0.2
sticking,
plus
because this
minus
is related
either
to
way.
the operations where we find without these heating systems, the sand sticking is
I
more
don't
on
know
the
how far you
vibro
could able to
feeders.
understand
Vibro
my
feeders are
explanation there.
those equipments which
But
makes
personally, you
the
should sit in
movement
the
of
machine and do
the
this.
castings of
Obviously,
sand
the
over
gentleman
the
would
top
ask,
of the deck
should have done all
airborne.
this.
It is not
Maybe
sliding.
if it is
shall
going to
be
give him a
airborne
better
based on the
input,
vibrations.
welcome.
So when I say airborne,
Sir,
if there
then
is a
there is one
sticking,
question
sand
from
sticking
Mr.
onto those
Shakti.
deck, obviously
Life
it will
of DISA
prevent
machine
the
chamber
airborne,
plates.
and then it will redraw.
In our case, it is 500,000
drain
extra. it
in
depends.
turn, the current taken by the equipment will go high and then
See, if
endangering
you
and
do
tripping
not
of the
replace
entire
the top
equipment.
chamber plate,
With the tripping
you
of
shall
every the
ensure
whole line would get
the
stopped.
gap
So this
between
is
the
one
pattern
of the
plate
issues
top
which we had
and
seen,
the top chamber
and
plate
we have
bottom.
evolved
There will
out
be a gap,
heater
okay?
systems underneath
That gap
the
is
deck,
to be
so
at
that
0.2
you
is
have a
what
temperature
the
controller
preferred
and you
gap,
have a visual
okay?
control. All
Because
the
the
things
sand
will be in
rain
place
says
so
being
that
0.2,
people who
anything
are
more than
just going around the
0.2
equipment can able
would
to see the heater in
endanger the
operation,
sand
can
coming
see
out
the
and
ampere
then
of the heaters,
causing
and you
some
can see what is the
intrusion
temperature of the
rejections.
deck
The higher
even
the
without
gap,
touching it.
the higher will be
And
the sand
you can
fins
see, you can
at the edge
ensure
of
that
the
there
chamber
is no
plates.
sand sticking onto
So
that
you
as
shall
the temperature
ensure
is
that
at this
there is no
particular level.
fins,
Because we have done an
sand
extensive
fins
research analysis
protruding from the
by
top
which
chamber
up to
plate.
this temperature
Normally,
there is no
by
sand
carrying
sticking
out
that can be
you should
seen
maintain
offline,
this and you should
based on
measure.
which
You
you
shall
can
have
able
a
to provide
mechanism of measuring
wattage of the heaters.
pattern plate
Okay.
top
So
to
such
the chamber
things
plate
become
bottom,
a
on a
maintenance
periodical
prevention
basis.
sheets,
Every
which
time
will
you
become
measure
a
and
part of
record
the
it every
equipment
time
when you go for
when
the
you change
new
the pattern
equipment.
plate.
This is an example.
So by having a very continuous monitoring, there may be a case where even the pattern needs
Now
to
we
be
talk about
built at the top.
the
Okay?
spare parts
If that gets
management and
left out, obviously you are
maintenance
creating
budget
a
controls.
higher clearance.
Because I'm
The more the
the
clearance,
maintenance
the
management
rapid
also
will be the
takes
wear out.
the
You have to
statutory and
understand.
legal
So minimize the
requirements
to
especially related to
0.025, not exceeding
the
0.3.
air systems.
Such case being,
like
you can able to minimize the rapid
pressure vessels and all that which
erosion.
comes under
And
statutory
to come
requirements.
straight
Okay.
onto
So
the life.
those things also
Actually,
become,
this is how
part
we
and
go.
parcel of
Life
the
is
maintenance
determined
management
by
systems. Obviously,
the extra
you need
clearance
to
what is
have
created. You make your own
checklist,
methodology of extra
internal,
clearance not exceeding 0.35
checks
or so.
for the relief or
whatever that
operations
comes at your factory, you
and,
can keep.
internal
Breaks
checks
India, if you
for
say
ensuring
about
there is no water
400,000
stagnation
to 450,000 shots is
also
what you
have
see. The top plate alone gets replaced at least 225, 250,000.
condition-based
Top plates
maintenance
we
management
replace twice.
methodology.
The rest of those plates
checking
replace
the
at
pressure vessel
single frequency and
thicknesses.
overall frequency.
So many things
can
can be done in-house, and also you shall interact with the government agencies
but
to ensure that
do not go
the
by
pressure
these
vessel
numbers.
certifications at
You
appropriate
go with the
periodicity are
clearance.
also being
Always
maintained.
I
So I'm not
insist
discussing much
upon
on the
measurements
statutory part,
and then
which obviously
taking
everyone
actions.
need to follow.
Not
We
with
now
just
talk about spare
somebody
parts
says so.
control.
No.
Okay,
You have
this
your
is
own
important.
measurement analysis, and then based on the
also with
measurements,
regard to the
you analyze whether
also explained
anything higher clearance would endanger.
need
Then
to
you go for
have the
replacement.
sales, whatever the
But
sales.
you
of
shall
this
have the
particular
practice of
foundry,
measuring
we need
through
to
feeler gauge
have a thumb
every
rule
time a pattern
upon
changes.
what should be the basic percentage of the sales which can be
Sir,
used
last
for
three
the
questions.
repair
There
and
are
maintenance
lots
budget.
coming in. I
Okay,
think
you shall
we'll
have
take the
your
last
own
three now.
methodology by
To set
the standards what you follow, because
lubrication
it may
intervals
vary
to
from industry
optimize
to
the oil
industry depending
consumption.
on the type of the foundries what we work in. Okay, so you shall have some basic controls by which
How to set
depending upon
lubrication
the
intervals
sales value
to
or depending
optimize
upon the
the
operational front.
oil
Okay.
consumption.
You can able to arrive
How to set
what
a
should be
frequency.
the percentage of
normally
the repair
when
and
you
maintenance
use
budget.
oil
What
lubrication,
you should
okay,
evolve
oil
at the beginning of
lubrication,
the
whenever you
financial
say
year or
oil
the calendar year,
lubrication,
as the case may be.
it shall be continuous.
So when I say
Let us take
maintenance methodology for the
these
cost
chamber
reduction,
lubrication,
spare
which is
parts
oil
cost
lubrication.
reduction.
Okay,
The concept
so
is
that will be a
first
pressurized
extend
lubrication.
the life of the part.
And
I have
there is no
explained
consumption
you
of the oil unless
the
otherwise
XY
there is
graph
a
where
oil leakage from
the
the gland
x-axis was
seals.
talking about increasing the time.
By
Increasing
main
the
terminology, no
MTBF,
leakages,
and
no water
y-axis
leakage,
talking
no
about
air leakage,
deterioration.
no oil leakage.
And I was
This is what
explaining
the
you how
step
we
one
increase
technology
the
of
MTBF
Jishu was
by carrying out the daily patrol.
When you say oil
by carrying
consumption,
out
inspection
because of
lubrication,
when I say
nobody
inspection, it is added
will,
upon the daily patrol. When I say
top up,
inspection, repair, and daily
there can be a
patrol,
top up of oil
adding
as
up
long as oil gets
the,
leaked only.
condition-based
that comes
maintenance
into picture.
and
Grease
time-based
lubrication,
maintenance,
yes,
as the case may be.
you need to
So
follow
when
the
you
grease
carry out
lubrication
all
as
such
mentioned
best
by
practices,
the machine manufacturer. You
obviously
follow the similar
life
grease
of
and do
the
it.
spare
But
parts
oil lubrication
gets
is normally a
extended.
closed
The
process.
R&M cost
It may not be an open
minimized.
process.
That is a area where
I think you
all
understand
along
the
we have
problem.
been talking about.
Oil lubrication
Then
is
you talk
where
about the
you
design
have oil
changes.
filled,
Okay.
and then
When you say
it is
design
pumped
changes,
into
then
chamber,
you can
and the same
there
oil
can be
gets
some
back to the filter,
spare part
and then
which
it goes
fails
back to the
very
tank.
rapid owing
And
to
this
the
is a
service
closed
conditions.
lubrication system.
So you can
That
now
is
go
only
in
where
for
oil lubrication can be
increased
used.
rated.
Otherwise, in a
spare
pumps,
part,
thereby
what do you call
the
a water pumps
serviceability
also.
and thereby the longevity of
system
operations
is
can
that
be improved.
instead of
So
grease,
those are the
they may have
design
oil
cups
corrections
with
which
a
I was
big
talking
wick
about.
means
About which you can able to
so they may have oil
increase the
cup
life
and they
of
pour
those
some oil
with
and
an
then
improved
close the,
design. Obviously,
close
the R&M cost would get
small
reduced.
this oil
Then
this
spare parts
so
reconditioning.
There
This
are
oil
cases
gets
where
absorbed and
you
through the
may not
wick
throw
it gets into
and
the
you may
bearing
do the
of the pumps. This is
reconditioning
old methodology.
and then use
Currently
spares. Only
okay.
grease lubrication
So that is
being
also
used. Where
another
there will be
method. This may not be
consumption.
applicable for electronic
Oil
spares and all that.
consumption again
It is
determined
applicable only for
with
those
the,
items which
when
are
it is
removed
closed.
for
Even
the
if it is
wear out
hydraulic oil,
and can
it is a
be
closed system.
added up with some
Wherever
hard
there is a
casing
leakage
material
at
and
the
to be
top of,
ground to the
you need
correct
to attack the
specifications and
leakage
can be
because
reused.
it is either
As the
due to
case may
post
be.
deterioration
Any
or
individual foundry
due
can
to
take a call upon this
non-attending
because
to
I'm
the
talking
BBM or
the
CBM
methodologies
methodology.
what are being adopted
There
across
should
the
not be
foundry
leakage.
fraternity.
That is more important.
Not necessarily be
Specifically
that
when
we
you say
follow this,
lubrication,
we follow that.
I
It is upon
don't
individuals
accept
to follow whatever the
consumption
truth
of oil for
and
lubrication
in-house
because it's a closed
manufacturing.
system.
There are people who can able
Nobody
to
uses
again,
oil for an open system.
please do not assume that
Open system lubrication, they use use only
This is
general maintenance
grease.
Management techniques on which
And solid
spare
lubrication
parts
like a
maintenance
graphite
cost to get reduced. These
also
are all
can
the
be used for
methodologies that
solid
can be
lubrication.
adopted. Okay, there are cases where you are equipped. You
I
can
suppose
make
I made him clear.
in house tools.
If he still has
and
some
then
queries,
he may write to
spare,
you, and I can answer him
indigenization
separately.
where imported
Sure,
spares
sure,
you
sure.
can able to get
Sir, then there
from
is one,
India,
Mr. Sudhakaran.
and then
Can
we
you
can
please
able to
brief
improve
about
upon the
optimal
cost.
checklist preparation?
On the spare parts categories,
there are consumables,
is not so.
there are a drawing
developed
adequate
space
sir,
and
and also machine space directly, which
Enna,
you
again I will
that
share
you
I will
secure
share the
from
presentation. As I
OEMs.
said, I will share the
on
presentation
all
to
these three cases, the
IIF,
consumables,
which you can share
obviously
to
you
the
fix
members.
up minimum maximum
Let them
reorder
again
level.
study.
ROI
That itself will
means it
give
is a
an answer,
reorder
because
level. And based
optimal
on which
once it comes
checklist
into
preparation reorder level,
I need to
automatically
explain the
system will
entire
generate
topic
what
purchase
I have
requisitions.
explained.
And
Then
because upon
the
receipt of the
question is
maintenance
not very
consumables,
clear. Incoming inspection is carried
Right,
out
sir.
and gets
So
into
we'll
the
anyway,
stock.
it is
Because
very-
when I say
normally the
checklist,
consumables can
it
be
starts
of
from daily patrol.
it's
Not
not
for
the
value
gentleman who
items
had posed
where,
this question
you
had
can
gone
have
through,
in
had
plenty
attended
and
the
it
first
might
program.
not be really affecting
See,
the
it starts from the daily
R&M cost.
patrol. Okay,
Then
it starts
there
from
are
daily patrol.
cases where
It comes into the weekly
C
checklist. It comes
category
into
insurance
fortnightly.
where
It comes into
very
monthly. It comes
sparingly
into
being used.
every
The
semester.
name by
It comes
itself
into
spells
yearly.
out the
So
insurance
many
pair,
checklists are
which
there.
is not very
So,
commonly
and
used.
what
Only
we
the event
do,
of any
because
failure, unforeseen
when somebody was
failure,
asking what is the
obviously
manpower
it
allotment
would take
for my equipment, for
even
my
a
machinery,
longer
for my
lead time
foundry.
to get those
Obviously,
spares
for
and
those
restore the
equipments,
equipment.
when you
So
list
such case
out all
being,
this
there will
checklist
be some insurance
and
spares
you
which
list
will be
out
kept,
the
which
quantum
you
of work
cannot
involved,
really
you
get rid
list
of.
out the allocation
So
of the
that's
people
what I
for
mean
that,
by
and
insurance
you arrive
spares.
at the manpower.
And also
Similarly,
those things
you will
can
have
be
to list
maintained
out
a very
those
minimum.
checks, what is required
There
for
are
me
some
to
spares
carry on a
which we
daily
develop
basis.
based
and all
on
that.
the
If we
drawings.
come, because
And
I
also
said this
assess
is a
the
common
stock level
maintenance
based
management
on our
program
own
I am
TPM.
taking.
Okay.
I am not
Because it is one
equipment
what
specific in
we
this
do the
case.
TPM
If
ourselves.
there is any
and we can
equipment
develop the
specific,
TPM
he is
ourselves.
asking for
Based
checklist,
on the
what
TPM
I
level
should
when
follow
it comes
for
in,
DISA,
then we can able
what I
to
should follow
give
for
the system
the furnace,
responsibility
what I should follow for
to generate
the crane.
the PR.
Then
upon
I can
reaching
able
the
to
TPM level,
provide
and
the
then upon
entire
the receipt of
checklist
the
on a
material,
daily or a
the
weekly or
spares
a
are
monthly
inspected against
specific
the
to those
specifications.
equipments, which
Like
might
the PM
answer this
analysis I
question.
said, you write down the specifications,
Got it, sir.
you do the inspection
Anyway,
of
it
the
is on
spare parts
YouTube, sir.
level,
Once they
assembly
can
level,
follow
sub-assembly
the
level,
program
and
on
write down
YouTube,
the
then they
actual
will be able to.
phenomena
Yeah.
in line with the
And
specifications.
sir, the
Is what
last
I said in
question
the PM
from
analysis.
Sanfits Unit
So
1,
again,
Coimbatore.
incoming inspection is also
Sir,
done in line with
DISA
the
is
specifications.
insisting
You shall have a clear
monetizer
specification.
industry
There can be
4.0.
some spares which are
Will it
proprietary
help
spares of
reduce
those
maintenance
equipment
cost and
manufacturers,
uptime
where
of
they
the
may not be
machine?
able to provide you the specifications. But you make your own
Again, $1 million
specifications
question.
with the available spare with you. You
If they
find
yes,
out and you measure the
then
hardness, you
the
measure
gentleman
what
might
is the
opt for
coating
it.
thickness, what they do. You
If I
measure all
say
the
no,
dimensions in microns.
then
To
I am
the
talking
accuracy
against
level, you
DISA.
can measure and you can have all such
Again,
things,
it is individual
database created. So with your own database,
work
you
upon
can
that.
able to check whether it
DISA
is in place.
monetizer
Because nobody will take an ownership upon premature failure of
new
those particular spares,
methodology, which
especially
is
when you
now being
approach the
prescribed
OEMs.
by
When
DISA.
there is a premature failure, they
But,
may not be able to undertake any
we should be
responsibility, and they
equipped
may
to handle
try
that.
to say that it is because of inadequate maintenance, or it is because of the
There is no direct
inadequate
answer from me
knowledge
for
of the
this.
operation
I
or something
suppose
like that.
people will
So
understand.
such case being, if
They
you
can
have
talk
your own
private.
database, and then
Got
upon
it.
incoming inspection, if you could able to find out
Okay,
even
sir.
with
With that, we have come to the
even
end
the
of the
spare
Q&A
before that is
sessions.
being put into operation,
We now
then you can
request
have a bigger
Mr.
hand
D.G.
to
Benakappa,
argue with
Honorary
the
Secretary,
supplier or the
IIF Southern
OEMs
Region,
where
to
from
propose the
the
vote of thanks,
spare is
please.
secured, and you can able to discuss with
Thank
them.
you,
Okay,
Vignesh.
that
Good
would
evening,
definitely
everybody.
pave way for them to
Good
have
evening,
a better
sir.
interactions, and the
As
knowledge
you told
level
that it is
with
Part-2 program by
OEMs as well,
Chennai
the
chapter.
individual user
Correct,
will get
Vignesh?
enhanced
Yes, sir.
together. It's
Correct,
a
sir.
win-win situation for
40th
both.
program.
Congratulations for conducting so many
Then
good programs
concept of
which
the
are
spare parts
useful
control,
for the
as
Foundry
I said
fraternity.
earlier,
Thank you
you
very
can
much once
categorize
again.
these spare parts into
And
A,
this
B,
is
C
zero
category.
maintenance approach,
Okay,
Part-2
this
by
ABC
Mr.
again on
S.Sundaresan,
a
sir,
VED
Senior Vice
analysis,
President,
where
Operations
V is a vital,
and
E is
Technical,
essential, and
West
D is
India Limited.
desirable. Okay,
Sir,
so
the
and
whole
A is a
program was
very
very
high cost
scientific,
material. Okay,
systematic
B is a medium
approach for
cost,
the
and C is
maintenance
a low cost
in
material.
Foundry
Okay, though it is
with
given both
proper
A and
documentation
B as a
guidance
very
also
high
you have
cost and high
given.
cost. I would say A high cost,
Participants,
B
one
moderate,
time
and
it
C
went
is a
95
is
plus.
okay. Okay,
Correct.
so to that extent, you can
Fantastic, sir.
able
And the
to
program
appropriately you
started
can design
right on the
what
time.
should be the
Just
level of those spares which you
elaborate
should maintain. Okay,
details are
this is
given by
applicable
sir.
more onto the maintenance
Regarding air
consumables,
compressor,
and also
definitely
with
people
respect to the
don't
spares. I
consider
said based on the
air
cost,
compressor as
based
a
on the
major power
insurance
consumer,
spare
but the way
requirement,
you have given the
based on the
presentation,
TBM concepts,
definitely it will
all
help
such things
Foundrymen to
take all
understand
this
how do we
experience
attack
into
on on the air
control,
compressor
and then
bit.
you derive at the ROI
Mr.
level. Okay.
Sundaresan
So
is,
when a store
definitely a
deriving the
enciphered
ROI level of
media
those
of
maintenance
Foundry
spares,
maintenance, because
obviously maintenance
this many information,
person who is well versed with
normally
all these
foundries
techniques
don't maintain.
shall
The
be
way you
approving
maintain
this
the
particular
document, the way
ROI in
you
such a way that
presented the things,
the maintenance
you
spare
are really
management can be
passionate on
really made
maintenance,
into
and
control. Otherwise,
very much
we will have some
thankful to you
firefighting
for a
exercises
fantastic presentation,
where there is a
even
breakdown
in
and you may
part
not have a
1
spare
and
in
part
time,
2
or
also. Thank
plenty
you
of
once
spares
again, sir.
available, and then it would end up
Also,
with
I would like to
increased
thank
inventory
SR
cost.
Chairman
Ultimately, we may
and
have
office
to
bearers of
give
SR,
a
IIF Chennai
justifications which
chapter
is
office
totally
bearer,
unworthy to the top
SR
management.
council members, past chairmans, NC members, past
Then I am
presidents
just
of
talking
IIF,
about MTTR. We
participants.
discussed
Thank
MTTR
you one
predominantly.
and all
It
once
is
again.
basically
Thanks,
called
Niklesh, for
maintenance to repair. Okay.
moderating the
So
program.
when we
Thank
say
you.
MTTR, how
Hoping,
to reduce
still
the
lot
MTTR?
of
MTTR is
bunches
to,
of
we need to
programs
see
are
the
there
avenues
from
by
Chennai
which it can be
chapter.
reduced.
Yes,
This
thank
is
you.
an example.
Thank you so
Okay.
much.
Where
Thank you, Sundaresan
this is
sir.
an online shot blasting
Thank you.
machine. These are
Thank
shot
you
blasting
all.
machine where
And
the online
thanks
shot blast
for,
drum inside the
for
chamber
IIF,
need to be replaced. Okay.
for
So
providing
you
this
see the
opportunity
Foundry roof
to
okay.
conduct this
So
program on
such
zero
case being there
breakdown
is not a
maintenance.
bigger revenue
And I'm
for
sure
us to
that this
remove
would
it from
enable
the top
the Foundry
when
team
the
to
whole
work
equipment
onto
is in
this.
place. So such
As
case
I
being
said,
earlier
again,
practice
the
is
skill
that
is more important.
we need
and
to
getting
remove the
expertise
entire
is all the more
machine
important.
and then
With this knowledge,
remove this
this
particular
should be a
drum out
stepping
and then
stone.
replace the new
People
drum.
should try to
Okay.
practice
But later
at
we
their
have
own
evolved
foundries.
out a methodology
And
by which
definitely
we can able
there
to
could be
remove from the top. Okay.
wherever there
With
could
a
be
new
obstacles,
methodology
they
by
can
which you can able
definitely
to
get away with,
reduce the
practicing
MTTR.
these methodologies. I'm sure that it would
The
definitely
result,
yield
the
a very
actual
good
MTTR
result.
exactly we could
Because
able to do in 2
uptime
days. The
of
whole
the
drum
equipment
replacement
would
can be achieved
definitely
in 2 days. You can
improve
remove
the uptime
everything
of the entire
and
line,
put the drum back
which in
into
turn
this, align it,
you
again put
would
the
see
top, all the
improvement on
vibrator
the
wheels in
productivity,
place,
on the quality,
provide
and
all
other
the vibrator
fronts
connections,
also.
check and hand over.
So I
So
want
obviously you can able to
every
this
one of
improves
you
because
who
you
are
will
very
get only one Sunday
sincere
or
enough
one
to
Saturday to take up
take
this
this up
maintenance.
and
So added up
deploy
with
across your
one
own
another day you
foundries,
can
and
able
then
to see the benefit for yourself. Allow this machine to be operational
make
for the
Foundry
line.
clean.
So
Please,
where the
do
production
join us
schedules are very
with
high,
the myth of
it
breaking
will be prudent
Foundry
enough to
being a
look
3D
for
industry.
improving
Make
the
Foundry
MTTR.
also in
When
line
I
with
say
the
improving
machine
MTTR,
shop.
just
And
this
thank
just
you
an
all
example because
once
there are
again.
100
Thank you.
ways and means by which the
Thank you so much.
MTTR
Thank you,
improvement
sir.
can be
Thank you
taken
very
up. When I say MTTR improvement,
Steven
obviously
Suraka.
we need to
Yes, sir.
we need to
Yes,
chart
thank you,
out
Sundaresan.
what are those
Thank you, sir.
suppose machine breaks
Bye-bye.
down
Bye, Vignesh.
and then
Thank
we
you.
are restoring
Thank
the
you, Sundaresan
machine.
sir.
It
Thank
had
you.
taken about 3.5 hours time. Let us just in case example. So 3.5 hours, you should have a breakup of those 3.5 hours. So how long did I take to analyze what has gone wrong? Okay. So the analysis and what I need to do, the action I need to see, this is one part. Second, when there is a spare replacement which is warranted. So how long do I take to secure the spare from my stores? How long do I do search for my spares? Because the earlier I get the spares, then the visibility in my stores is much better. That is what an indication. The earlier I do the analysis, then my knowledge level of the machine is better. Is what the inference is that. Okay. So when I chart out, then how long do I take to replace the spare? That is part number 3. Then how long do I take to test the machine to see whether the performance is exactly in line with how it used to be earlier? Then hand over the machine. So these are the 4-5 basic breakups which I make. You can make as much of breakup as you want. Okay. So when you do all such breakups, you can able to be the maximum time what it takes will tell you where you need to correct to improve the MTTR is what it means. So when I take more time for the fault diagnosis, obviously our understanding level of the machine is not so adequate. Is what is the understanding? Is what the outcome is. Our attention shall be in such a way. Of course, breakdown has happened and you have taken more time for the analysis and you restore the machine. That part is done. Okay. Time lost, you can't again gain. What you can gain for future, I need not to waste the time. That is what the gain what you need to have. So such case being what you got to go, this is taking higher time. My maximum portion, 70% of my portion of the time in the restore of the machine is on the diagnosis front and how I diagnosed for this particular failure of this part. Okay, so then I need to concentrate only upon education and training of my team, including the maintenance technician to the maintenance engineer. Okay, so that should be the attitude I go. Suppose if the spare, if I am spending more time in removing the old defective spares, that means it is difficult to approach. It comes under the category of difficult to approach, difficult to clean, difficult to adjust. So those categories it comes in. So obviously you need to look in for the design improvement where if there is any possibility of approaching it much easier. Or if you could not able to do that, how fast can I have some other tools? So can I design some other jigs and fixture? Can I design something else which can be enabling me to remove this faster? So all this methodology should work. Thereby you can able to improve such failures in future if at all it comes. Okay, should not come. If at all it comes, that should be the way. Third, if it takes more time for me to get the spares from my stores to the maintenance machine area, then my visual control analysis system in stores is bad. Obviously, I need to improve upon my visual control systems. My system ensures that once I just key in the part number, it shall immediately show me which rack where it is kept in. Immediately, I should be in a position to give a material inward receipt and then take the spares and get back to the equipment. So with this, and then the time when I find the time I take is very high upon replacing the spare into this particular equipment. That means my hand skills are bad. I can analyze that this is a problem. Then I can remove this spare because the faulty spare I could able to remove it in any way. Because I don't have to pay much of an attention. Then I could, my store systems are so good that I could able to retrieve the spares from stores and keep near the machine fast. But this assembling the spares into this equipment now, it takes more time. So this is a case 4. Such case being my hands-on experience is bad, is what it means. So what I need to do, again, I said earlier, knowledge, skill. Skill is applying the knowledge into the work. That is hands-on experience. So we need to improve upon hands-on experience. So what do you say? How am I to improve the hands-on experience? So only when there is a breakdown, I have an opportunity to remove and do. So when there is no breakdown, what am I to do? You mean to say every week I should remove this and again replace it with a new spare? So will that not endanger my maintenance equipment of the machine by itself? Will that not increase my R&M spares? Because once I remove it, I need to replace it. I can't be just using the same. So all these questions will come. So what do you say for that? So offline, you shall see the engineering is same. Okay, you can create some models offline. Thereby, you can provide some hands-on experience to your operators. Not necessarily the entire design machine has to be aside where you need to work. The particular the assembly what the machine is. If there is some let us assume there is some hydraulic cylinder in that equipment. Obviously, you can have another small specimen cylinder outside such a way that you can able to impart the hands-on experience amongst your maintenance team, how to assemble and how to what are the methodology to see the lip seals are in place while carrying out assembly. How are you to ensure that the lip seals are not damaged? All such a practice. How I should use some other guide, okay, by which you have a taper inside. Thereby the lip seals goes smooth into the taper, and the taper is kept exactly in line with the cylinder bore, so that the whole piston with the seal slits into the cylinder without any discomfort. So you make some methodology, make some arrangements, make some teachings offline with similar engineering models. Thereby the education becomes easier. Thereby the hands-on skills also gets improved. So these are some of the methodologies one can work based on the outcome of how they improve upon the MTTR. So there we come to the end of my session, and in line with earlier discussions, what one of our members who had asked on the air control system, specifically I think Mr. Shanmugam of Madras Engineering would ask, I will take brief notes on what are the air control systems that are being followed here in Brakes India. So the compressed air systems, which consisting of main parts as compressed air production, compressed air distribution, and end users. Okay, it starts with the compressor and line with a filter, air receivers, and also air dryers, pressure regulators, and goes into the equipment user end. So this is how compressed air distribution will be there in any industry, not necessarily a foundry. In any industry, it will used to be like this. So what are the air management controls? What we follow here? Number 1 is a compressed air leakage usage awareness. Then air leakage detection and immediate corrections. Number 3, alternate uses of compressed air. Number 4, compressor performance monitoring. And 5th is a continuous monitoring and improvement. These are the methodologies about which I explain one after another. When I say compressed air usage awareness, see you try to have these boards, large boards in the local language written, and what are going to be the ill effects of when you use compressed air for a purpose which is not meant for it. Also, you can mention saying that if at all the nozzle size what you use for cleaning operations or whatsoever, with the pressure of operation what it is, how much it is going to cost for the company, what is the energy which is going to get consumed by using the various diameter of the nozzles what you use for the cleaning purposes. Okay, and you can very well clearly mention do's and don'ts. Okay, air leakage detections and preventions, we can use ultrasonic you can use acoustic cameras. We will see in deep what are the techniques that are being deployed. Then alternate uses of compressed air, where you can go for, in our case, I'm talking this case, you can, wherever the compressed air cleaning is there, you can go for some blowers, okay, which will be able to be less energy consuming when compared to the compressed air. Also in our case, where the PAB pump, which is a vacuum generator using the compressed air, which works on the Venturi principle, using a compressed air with a nozzle arrangement, where you have a vacuum created at the neck area, which is predominantly used for the core holding purposes in the molding machines. Okay, so where we replace this compressed air system with the dynamic vacuum pump, where which we could able to achieve the vacuum flow volume as well the vacuum pressure, which is required for the core holding purposes the molding machine. Then the compressor performance monitoring, various methodologies. It is also like a condition monitoring maintenance management systems, what I talked about. Shock pulse measurement in the compressors, vibration measurement, thermal imaging camera, and IR gun, use of temperature. These are various performance monitoring systems we use. And continuous monitoring improvement, where compressor performance report and shock pulse measurement report, which we call it SPM report, and then provision of VFD for the compressors. So these are the techniques about which individually we'll see how we go about. On the methodologies for air leakage detections, basically you can able to listen and feel, okay, where this is very simpler, no expenses involved. All the lines and compressed lines, you shall try to see whether there is any leakage. You can hear, or there is no special tool required. People can touch upon, all such things can be seen. But the disadvantages is only effective for larger leaks. Where there is a larger leaks, it will be very, very noisy and people can immediately attend to that. Where it requires a direct physical contact, must be able to hear above the plant. The decibel level shall be hearing above the plant equipment, and will not work for most of the leaks. Very, very, very micro small leaks and all, we may not be able to feel and we may be able to attack. This is one of the major disadvantages. And no information on such leak volumes. Okay, that is also very important. Such a smaller, very small leaks, these things will never get accounted anywhere, and it involves a lot of energy, compressed air energy. Then second methodology is use of soap water. Soap water, the advantages, again, this is also very simple, reliable technique, where you can able to definitely predict, you can definitely see, rather predict, you can see for yourself, there is a leakage here, no special tools required. But disadvantages being a time consuming method, it requires direct physical contact again, like how the earlier case, seeing and doing it, feeling and doing it, and no information on the leak volume. Okay. Third front is ultrasonic, use of ultrasonic. Advantages being it is very fast and accurate methodology. It detects leak as small as a pinhole. Even a small pinhole it is able to detect, and no plant downtime. When the plant is in operation, we can do all this, and no physical contact. Okay. But disadvantages, it requires a special equipment. Acoustic camera, the leak is calculated by the camera based on the sound value. Earlier, I was talking you about the thermal imaging camera. Even last week, I did explain about the thermal imaging camera that are predominantly used for condition-based maintenance in high voltage electrical systems. Also, in any of the equipments where the temperature is higher, by virtue of the change in the color, you can able to see whether the contacts are loose and all that, you can able to take actions. This camera is acoustic camera. The name by itself, acoustic, it talks about the leak, air leak, noise. It is determined. It determines the noise data based on which the leak is calculated. Okay, and it is expressed in decibels. And 124 microphones to form a very accurate acoustic image. That means the number of microphones are so accurate that you can able to absorb even the slightest air noise when there is a leakage, and able to image the desired direction also. But this also requires a special equipment on the disadvantage front. So how we go about now? The air leakage is captured by an acoustic camera. You could able to engage people from outside. If you are not securing such equipment yourself, there are people available outside who can able to help you out at a very, very nominal charge to take care of these things. So I have just listed out those locations and equipment wise. where the problem of the leakages and the decibels, what you see. And it also talks about the liters per minute. This is the air leakage, quantification of the air leakage, and leak to be arrested by so and so people, completed so and so. And this is the total CFM. Okay, liters per minute, again confirm, changed into cubic feet per minute. So now we can see the before after camera, where the acoustic camera, you have a hotspot and there is no hotspot after correction. Air compressor efficiency calculations. We have a regular practice at periodical intervals. The compressed air, because internal leakage can also happen within the compressor. If compressor maintenance is not being done properly, there could be an internal air leakages within the compressor, which may not be visible outside on the joints or the pipeline. So such case being the efficiency of the compressor is lower, the volumetric efficiency of the compressor is lower. So how do we calculate the volume of the receiver, the cubic feet? Okay, obviously the compressor will be attached to a air receiver. From the air receiver, it is given connected to the equipment levels through the distribution system. And the air compressor capacity, when you have the compressor, obviously when you purchase a compressor, you have the compressor CFM is specified by the OEMs, like 300 CFM, 320 CFM, 500 CFM or so, cubic feet per minute, okay, which is a FAD, okay. Then load and unload pressure of the compressors, time in seconds between load and unload, okay. So now the formula what we apply, air compressor and CFM is equal to Vp into 60 by T, where V is the volume of the receiver in cubic feet. Normally 2 liters receiver, 3 liter receiver, 1 liter receiver and all be used, okay. You convert the 1 liter receiver into cubic feet. Okay. Then P is the pressure difference between load and unload in atmosphere. When I say atmosphere, there are 3 different pressures. One is atmospheric pressure, which is 1.03 kg per square centimeter. Another is gauge pressure, which is connected to your machines or connected to the air receivers. The gauge, when the receiver is empty, the gauge will read only 0. That means still atmospheric pressure is there, but gauge will not read atmospheric pressure. As far as gauge is concerned, atmospheric pressure will be read as 0 in the gauge pressure. Then absolute pressure. In the basic thermodynamics, we always use absolute pressure. We always use absolute temperature in the thermodynamics. Okay, so such case being the absolute pressure is atmospheric pressure plus gauge pressure. So that's what it means here. So where the CFM of the compressor designed air compressor efficiency is calculated CFM by, you see you find out the air compressor CFM by Vp and T. By doing this, you arrive at the value. But whatever they calculated with the designed by the OEM, the ratio of which will give you the air compressor efficiency. So how it is done in Brakes India in our SF1. SF1 is Sand Foundry 1 and Sand Foundry 2. We call that terminology. So compressor make is Atlas Capco. It is a 1000 CFM compressor, 160 kilowatt powered. So the rest and all is okay. Forget all that. Then time calculations, receiver pipeline. When I say receiver plus pipeline, the receiver volume is 3000 is the receiver, 3000 liters receiver volume. 190 is from the compressor to the receiver. The connected pipeline, it is a 4-inch pipeline. So with the length of the pipeline, it is calculated. For better accuracy, it has been calculated the pipeline also. Okay, when it is very nearer to the compressor, even then it is better that you take the pipeline, intermediate pipeline connecting the compressor to the receiver. So 3190 liters, which is 112.64 cubic feet. Okay. Then the load pressure is 6 bar. Then unload pressure is 7 bar. The difference between load pressure and unload pressure is 1 bar. So is what we see. So atmospheric pressure is again 0.97 because 1.03 bar is atmospheric pressure. So that is why. So 1 bar gauge pressure is converted to 0.97 atmosphere is what it means. Then time taken to unload is 6.6 seconds. Okay. So what it means that I shut off the receiver because the receiver now is connected, all the equipments inside, it is all shut. Okay. So now I shut off this and it time takes for the compressor to fill up the receiver and pipeline. So that is the only volume I am taking now. And then once it is done, then it gets unloaded. Immediately after filling it up, upon reaching 7 bar, it gets unloaded. So the air compressor CFM now we are calculating 112.64 in CFM multiplied by the P, that is atmosphere 0.97 multiplied by 60 is a constant factor divided by T, it takes 6.6 seconds. So you arrive at 991 CFM. So designed compressor CFM is 1000 CFM. So the efficiency is 991 by 1000, which is 99.12 is a efficiency. So you have your own efficiency. Normally volumetric efficiency should be always higher than 96%. That should be the thumb rule what one should have. Similarly, guideline for air leakages. This I talked about the compressor internal leakage, where the efficiency, volumetric efficiency of the compressor is calculated. Now we come into the lines. This compressor is beyond the receiver. It is connected to the equipments now. Okay. And I have also explained to you how at the equipment level you are taking through the noise imaging camera and how you are attacking at the equipment level you are seeing. Now you are talking about intermediate pipeline level. The pipeline level, the shut off the air operated equipments, the equipment at the equipment inlet, you shut off all that, but the entire airline will be open to the receiver system. Okay, they run the compressor to charge the system. Okay, to set the pressure of operation. Okay, if it is going to be 7 bar, run the compressor, it gets shut off at 7 bar. That means all the piping, compressed pipelines inside the company is completely pressurized, but those equipments line in inlet walls are shut off. That is the case now. We are talking about the air leakages across pipeline inside the complete foundry. So note the subsequent time taken for the load unload cycles, because it may you take some 2-3 occasions, even for 8-10 occasions I have written here. So you take more number of load unload, so that obviously you calculate upon the correctness of the data will be very good. So the system leakage is calculated at percentage leakage is equal to capital T. Capital T is the on time and small t is the total off time. So capital T divided by capital T plus small t in 100 is equal to system leakages. This system leakages can be calculated. You can see the actual report here. This compressor capacity is 16 cubic meter per minute, which is 572 CFM compressor. Cut-in pressure is 5.7. Cut-out pressure is 6.2 bar. Compressor load is 92 kilowatt. And unload current is 28. Unload kilowatt drawn is 28 kilowatt. So average load time. So it takes load time of 0.59 minutes and average unload time is 5.34 minutes. That means the complete compressed airline inside the plant is charged at 7 bar. Okay. Now none of the machines are operational. All the valves to the machines are shut. Now the air is pressurized in the system only. So compressor is switched on. Once it gets unloaded, you wait until what time it gets reloaded again. It takes 5 minutes and 5.34 minutes to get reloaded again. So that means the airline inside, there is a leakage only based on which this 5.34 minutes later, this is again getting switched on. So system leakages, you find T plus T divided by capital T plus small t into Q, where I find the capital T is here. You find this working out to leakage quantity per day, so much of cubic meter, Q into 24 into 60 cubic meter per day. Okay, so you are trying to save to the extent of about 0.9489505 kilowatt hour per meter cube. Okay, this so much of accuracy need not have to be there. By deploying this, you can able to understand the effectiveness of the leakages inside the pipeline, based on which again compressor when run on load, obviously you can see it draws 92 kilowatt. When run on unload, it draws 28 kilowatt. So the energy efficiency can also be improved by attacking the pipeline leakages. Now coming on to the compressor by itself. So compressor, we follow practice of shock pulse measurement both at the compressor end as well as at the motor end. So with the inlet, the equipment manufacturer themselves, they provide the decibel input dBi, and also you measure through the SPM meter, you measure what is the dBm output. So when it is within the control, normally we keep less than 20 dBm, we keep this as a green zone. And yellow zone, when it is up to 35, we keep this in yellow zone, after which you need to take real actions. When it comes to yellow zone, you need to take real actions for replacement of the screw element. Screw element, again, it depends upon the maintenance that is being followed in the compressor, like the oil replacement times, oil filter times, air oil separator replacement times. All such things should get into account, and also the temperature of operation also plays a vital role. Mostly in compressor rooms, you shall have some exhaust system so that the room temperature shall be maintained near ambient. obviously the exit of the compressor will also be much higher. So by providing such a better exhaust system, you can able to maintain the compressor temperature, by which it would also be prudent to enhance the screw life, longevity of the screw life. Compressor electrical energy conservations, we could use try to use VFD for these are all some of the avenues by which you can able to improve. Okay, then replace pneumatic vacuum pumps, the electrical vacuum pumps, air leakage audits can be done, and then replacing compressor motors with IE3, IE4 rated motors together with VFD. So we try to plot the kilowatt hour per ton of metallics, what the total compressor energy over month wise, and these are the methodologies what I have explained to you. Changing of this vacuum pump using a compressor with a vacuum motor itself, and leakage identification we also discussed, and introduction of the VFD, where it could be able to tremendously increase. When you use VFD, you shall be in a position to judge whether it is applicable to adapt VFD only when the loading factor, unloading factor is when the compressor is getting unloaded, when it is underutilized, where the equipment, where the plant request is only about 300 CFM, let us assume so, where you have 800 CFM compressor installed in your system. Obviously, the compressor utilization is very much underutilized. Such case being, the VFD would play a better role. If the compressor capacity is exactly in line with the usage, so obviously, such case there is no necessity for VFD. VFD may be an extravagance and it might not add any value for energy improvement. Okay, so alternate sources, potentially inappropriate uses of compressed air, drying and the process of cooling, personal and workplace cooling. You shall not use compressor. People, they blow compressed air themselves onto their own dress or cleaning the dust. All such things is totally uncalled for. Vacuum generators, you shall not use compressors. Air-driven motors, cleaning part, normally it is not applicable to use compressors. Even panel cleaning and all, it is better that you use only blowers. That would be more appropriate. And alternate use of compressed air, low pressure blowers, as I said, and electric fans, dedicated vacuum pumps, electric motor, and low pressure blowers and or brooms which can be used. The benefits of implementation: automated load scheduling can be done, better compressor efficiency, controlled running hours of the compressors, reduced waste air, and leakage loss reduction. Okay, this is just an example, the case study where the cores are being transported to the core setting machine of the molding machine. They use compressed air for cleaning that, so that is replaced with a blower instead. Again, electrical ladle lining breakers, they are using compressed air lining breakers replaced with the electrical vibrators. So some of the examples which I have shown. Okay, thank you for your patient listening, and we come to the end of the subject. So I'm open for any of your questions.
Thank you, Sundaresan sir, for a very clear and relatable presentation on how to achieve zero maintenance, methods for maintenance, cost reduction, spare controls, and a very special presentation on air. So thank you very much. We are indeed fortunate to have a very hands-on and practical Foundryman gentleman talking to us about his topic that he loves. So thank you once again, Sundaresan sir.
Thank you, sir. Thank you.
Can we have any questions, sir? We have any questions?
Yes, sir. I am Shanmugam from Madras, sir. Sundaresan sir,
Yes,
thank you very much. Thank you. You have done a fantastic, exhaustive research on the air analysis. It overshadowed the zero breakdown maintenance. Really, we are very much thankful to you. Thank you very much once again.
It is my utilities team, those who helped me out, because you did specifically ask for this compressed air management system. So I requested my utility team. So they had prepared me, and then of course we are also working with them. So what are the credentials to go directly to the utilities team?
No. You have done a lot of research on this one. Thank you very much, sir. One more small question, sir. Is there any specific maintenance cost per kg or scalable for your foundry? For idea, because
Sir, I
everybody
may not be able to reveal this at, I
Huh?
may not be able to reveal this at this juncture.
No problem, no problem.
Yeah.
No problem, sir, no problem.
Because that is the reason why I said every individual foundries, they have their own R&M budget, and they know their own sales and they know their own production. So with their own experiences, they can evaluate the percentage of the R&M cost with regard to their production levels. But maybe I can talk separately on this.
No problem,
Sorry.
sir. Thank you very much. Thank you, sir. Okay. Thank you.
Sundaresan sir, there is a question in the chat box. Please give us an idea on manpower before and after the TPM methodology for a foundry of your status.
See, basically, TPM methodology does not talk about removal of the manpower. Okay, there is no threat for reduction of the manpower. Nobody is going to go out. Okay, what we are trying to see, the effort what one puts into an equipment would get drastically reduced upon following such practices. When I say my machine, I own the machine concept, it is a total operational team. They take into confidence. There need not have to be a separate maintenance team by itself. You assume there is a maintenance team, there is a production team. You assume so, okay, in a normal industry. So I don't number here. Obviously, when you merge together, there need not have to be plus operation plus maintenance will not be there. It can be one and off. Just an example I'm telling. Okay, let me not number exactly, but nevertheless, the people who are taking care of the maintenance, they don't have to be afraid that just because the production has taken up the entire maintenance management themselves, they are not going to be out of the job. Their level is to enhance into next level. So perhaps that you could able to see the level of the exhaustive work what the utility team have done with regard to the air management. Once operation team taken over the entire maintenance, you can work on to a very high end on the rest of those areas, which should be definitely beneficial for the organizations. So let us not talk at this juncture about a reduction of the manpower. Okay, especially when they are permanent people, you may not be able to reduce them offhand just by following the maintenance management. Rather, you can think of improving the productivity by zero breakdown. You can think of improving the productivity with a higher knowledge. You can think of improved quality level with the reduced rejections. You can be proud of no customer complaints. Okay, thereby the everything gets enhanced with the same team. You don't have to employ a new team for improving the productivity and so on and so forth.
Right. Sir, any further questions for Mr. Sundaresan? You can either unmute yourself and ask the question, or you can put it in the chat box. Mr. Ishwar, good evening, very good evening. Fantastic presentation, a very elaborative session. Is there a standard calculation or a formula to arrive the manpower required for a plant?
There is no standard formula. The question is, you own your shop. So you know there are how many machines in your shop. So you list down all those machines and then you list down all those maintenance checks, because we talked from the very basics. Okay, so you list down all the checklist what need to be deployed. So to carry out all the checklist, how many people requirement? Again, we did all this. We did all this 20-25 years. We did all this exercise. Okay, we ourselves do not know how to deploy people, how to make both maintenance and the production together. So you have to shift wise. You need to deploy those people for carrying out, because the machines are firm now. The checklists are at least for the time being firm. Okay, tentative time being firm until you amend the checklist. Let us assume the checklist also now firm, and then once for carrying out such a checklist, what is the manpower requirement? All the down the 3 shifts, that also you need to calculate and you can arrive at. So individuals, depending upon the magnum of their foundry plant, they can derive it. But as such, There is no specific formula like that 100-ton foundry will have 10 people like that. It is not like that.
Right, sir.
First, let us try to have zero breakdown approach. First, that is more important. That is the first aim, only for which the entire class we have been conducting. And let us, with whatever the support you have, and if you keep doing this, you yourself will evaluate. The sense, if there is if you could not able to achieve, and you do the analysis, obviously when the analysis is ending up with the knowledge or ending up with inadequate manpower, it may be also. So such case being, it gives you an indirect idea whether your manpower is adequate or not. So it is upon our own methodology how we follow this very religiously and then arrive at our own this thing. First, there shall be, because you can't experience this and then arrive at these figures. Obviously, you can do the planning properly and then you arrive at some manpower based on which you work. And when you continuously work, there can be some plus minus here and there, which you can set right over a period of time.
Sir, there is one more question from Mr. Shanmugam of Madras Engineering. Any idea about ultrasonic or acoustic camera price?
I will be able to provide this to IIF after the completion of this session. So you can pass it on to Mr. Shanmugam.
Done, sir. Okay.
Yeah. On hiring methodology, or also if you want to own it also, I can provide the data.
Okay. Yes.
And
yes.
I think my utility team is also present in this meeting, present in this forum.
Yeah.
They should also be noting down this question and we will do that. Yeah.
Okay.
So acoustic camera, acoustic air, acoustic control, you need the price.
Yes, sir.
Okay.
Sir, and then there is one question from Ms. Kamal. Is there any standard for pneumatic joints for header line into machine?
The best way is to go for aluminum now. Earlier days, we used to be having our own GA pipes with a coupling connected and all that, with all clamps everywhere. But that is bound to get leakages. The best way, the standard is nowadays all aluminum pipes with couplers where it is a shrink fit. Straight away you fit into that. It gets into the shrink fit and absolutely zero leakage. A lifetime. That's the best way. It is not so expensive when compared to the conventional GE pipeline, but it costs 1.3 times more. But you can fit and forget.
Okay. Yeah, he is also said thank you. Then Mr. Dharmaraja has asked a question, sir. Any idea about best mismatch can be achieved in DISA vertical line, mm?
0.2 millimeter.
0.2 millimeter. What are the action need to be taken to reduce to reach the best level?
$1 million question. Okay. For the mismatch, there are about 10-15 points. I will cover at least the maximum what the person could able to understand. What you need, there are two types of calibration to ensure the mismatch in control. One is static calibration, another is dynamic calibration. Static calibration, we talk about the static calibration. We take the PP and SP. When I say PP, it is a pressure plate and SP is a swing plate. The two halves where the toolings are mounted, the pins, the diameter of the pins, the height of the pins with respect to the bottom plate. This is to be taken up, okay, on the machine front. And there is a mold guide. When the PP travels on the bottom plate itself, before it goes to the automatic mold conveyor, there will be a mold guide. The wear out of the mold guide is also equally important. Whenever any new chamber plates are replaced upon the time-based replacement or condition-based replacement, the first mold after the new chamber plate is made, the first mold which comes out of that, you loosen the mold guides on either side, both left side, right side, and you need to press the mold guides exactly against the fresh formed new mold and tighten it. And you shall use light to see there is no light gap from the top to the bottom, so that the butting of the mold retainer exactly butting the mold without any air gap. So when there is any undue wear out, you will be able to see the light coming out, and that gives you an inference that requires a replacement. So this is the first area where the mold comes out. Then it gets into AMC, automatic mold conveyor. The automatic mold conveyor, it is operated through thrust bars on either side. Again, thrust bars which presses the mold and then it transfers the mold to one pitch. Again, releases the mold and comes back to the home position. So during this movement, these thrust bars shall be centrally aligned. That is very important, which can be checked for a AMC alignment. And thrust bars are to be checked for free movement. Sometimes because of continuous metal pouring and all that, there can be a possibility of the thrust bars at one end get struck. So we shall try to move the thrust bars by hand. That's a logic where you could able to move it by hand with one person. Okay, so that check we need to do, and the thrust bars on either side shall be centralized. That adjustment also has to be checked with a thread running at the center of the AMC. Once you do all this alignment and also AMC rails on which the mold is moving, there can be 3 segments, there can be 4 segments. The alignment of the rails are to be checked with the water columns. That also is very important. That can be done on a monthly basis, but all other things are to be done on a weekly basis. Once you clamp the AMC, there is no mold. AMC is thoroughly cleaned, machine is thoroughly cleaned, and AMC is clamped. So on the clamped condition, the maintenance technician or maintenance manager, whomever carrying out the job, should sit on the machine bottom plate, and he should sit means he should lie down. Okay, and you should see the thrust bars exactly. It is in one plane. There shall not be any variations thrust bar from the inlet thrust bar to the outlet thrust bar. Absolutely, it shall look like a string of a same line. So this is very important from the mismatch. Okay. So when you carry out this, these are all called mechanical adjustments on the machine and AMC alignments. By carrying out all this methodology, you can assure that the mismatch can be well under control within 0.2 plus minus either way.
Great, sir.
I do not know how far you could able to understand my explanation there, but personally, you should sit in the machine and do this. Obviously, the gentleman would ask, should have done all this. Maybe if it is going to give him a better input, welcome.
Sir, then there is one question from Mr. Shakti. Life of DISA machine chamber plates.
In our case, it is 500,000. Again, it depends. See, if you do not replace the top chamber plate, you shall ensure the gap between the pattern plate top and the top chamber plate bottom. There will be a gap. Okay, that gap is to be at 0.2 is what the preferred gap. Okay, because the sand grain size being 0.2, anything more than 0.2 would endanger the sand coming out and then causing some inclusion rejections. The higher the gap, the higher will be the sand fins at the edge of the chamber plates. So you shall ensure that there is no fins, sand fins protruding from the top chamber plate. Normally, by carrying out you should maintain this and you should measure. You shall have a mechanism of measuring the pattern plate top to the chamber plate bottom on a periodical basis. Every time you should measure and record it every time when you change the pattern plate. So by having a very continuous monitoring, there may be a case where even the pattern needs to be built at the top. Okay, if that gets left out, obviously you are creating a higher clearance. The more the clearance, the rapid will be the wear out. Try to understand. So minimize the clearance to 0.2, 0.25, not exceeding 0.3. So such case being, you can able to minimize the rapid erosion. And to come straight onto the life, actually this is how we go. Life is determined by the extra clearance what is created. You make your own methodology of extra clearance not exceeding 0.35 or so. Okay, whatever that comes at your factory you can keep. Brakes India, if you say about 400,000 to 450,000 shots is what you say. The top plate alone gets replaced at least 225, 250,000. Top plates we replace twice. And the rest of those plates replace at a single frequency, and overall frequency being 450, 400, 450,000 shots. But do not go by these numbers. You go with the clearance. Always, I insist upon measurements and then taking actions. Not with just somebody says so. No. You have your own measurement analysis, and then based on the measurements, you analyze whether anything higher clearance would endanger, then you go for the replacement. But you shall have the practice of measuring through a feeler gauge every time a pattern changes happened.
Sir, last 3 questions. There are lots coming in. I think we'll take the last 3 now. How to set frequency lubrication intervals to optimize the oil consumption?
Please say it again.
How to set lubrication intervals to optimize the oil consumption? A frequency. How to set a frequency?
See, normally when you use oil lubrication, okay, oil lubrication, whenever you say oil lubrication, it shall be continuous. Okay, let us take a DISA chamber lubrication, which is oil lubrication. Okay, so that will be a pressurized lubrication, and there is no consumption of the oil unless otherwise there is an oil leakage from the gland seals. By main terminology, no leakages, no water leakage, no air leakage, no oil leakage is what the step 1 technology of Jishu. When you say oil consumption, because of lubrication, nobody will top up. There can be a top up of oil as long as oil gets leaked, only that comes into picture. Grease lubrication, yes, you need to follow the grease lubrication as mentioned by the machine manufacturer. You follow the similar grease and do it. But oil lubrication is normally a closed process. It may not be an open process. I think you understand the problem. Oil lubrication is where you have an oil filled and then it is pumped into a chamber, and the same oil gets back to the filter and then it goes back to the tank. And this is a closed lubrication system. That is only where oil lubrication can be used. Okay. Otherwise, in a pumps, what do you call water pumps or so, there may have the earlier system is that instead of grease, they may have oil cups with a wick. Wick means velakutiri madri. So they may have oil cup and they pour some oil and then close the wick, close the small this oil, this thing. So that through this oil gets absorbed and through the wick it gets into the bearing of the pumps. This is old methodology. Currently, only grease lubrication is being used where there will be a consumption. Okay. Oil consumption, again, it is determined only with the when it is a closed. Even if it is a hydraulic oil, it is a closed system. Wherever there is a leakage, there is a top up, you need to attack the leakage because it is either due to forced deterioration or due to non-attending to the TBM or CBM methodology. There shall not be leakage. That is more important. Specifically, when you say lubrication, I don't accept consumption of oil for lubrication because it's a closed system. Nobody uses oil for an open system. Open system lubrication, they use only grease. And solid lubrication like a graphite also can be used for solid lubrications. I suppose I made him clear. If he still has some queries, he may write to you and I can answer him separately.
Sure. Sir, then there is one Mr. Sudhakaran. Can you please brief about optimal checklist preparation?
Question is not so adequate, sir.
Again,
I will share the presentation. As I said, I will share the presentation to IIF, which you can share to the members and let them again study. That itself will give an answer, because optimal checklist preparation, I need to again explain the entire topic what I have explained, because the question is not very clear.
Right, sir. So we'll anyway.
Because when I say checklist, it starts from daily patrol. I do not know the gentleman who had posed this question had gone through, had attended the first program. See, it starts from the daily patrol. Okay, it starts from daily patrol. It comes into the weekly checklist. It comes into fortnightly. It comes into monthly. It comes into every semester. It comes into yearly. So many checklists are there. So, and what we do, because when somebody was asking what is the manpower allotment for my equipment, for my machinery, for my foundry, obviously for those equipments, when you list out all this checklist and you list out the quantum of work involved, you list out the allocation of the people for that, and you arrive at the manpower. Similarly, you will have to list out those checks, what is required for me to carry on a daily basis and all that. If we come, because I said this is a common maintenance management program I am taking. I am not equipment specific in this case. there is any equipment specific, he is asking for checklist, what I should follow for DISA, what I should follow for the furnace, what I should follow for the crane. Then I can able to provide the entire checklist on a daily or a weekly or a monthly specific to those equipments, which might answer his question.
Got it, sir. Anyway, it is on YouTube, sir. Once they can follow the program on YouTube, then they will be able to.
Yeah.
And sir, the last question from Sanfits Unit 1, Coimbatore. Sir, DISA is insisting monetizer industry 4.0. Will it help reduce maintenance cost and uptime of the machine?
Again, $1 million question. If say yes, then the gentleman might opt for it. If I say no, then I am talking against DISA. Again, it is the individual to work upon that. DISA monetizer is a new methodology which is now being prescribed by DISA, but we should be equipped to handle that. There is no direct answer from me for this. I suppose people will understand. They can talk private.
Got it, sir. Okay, sir. With that, we have come to the end of the Q&A sessions. We now request Mr. D.G. Benakappa, Honorary Secretary, IIF Southern Region, to propose the vote of thanks, please.
Thank you, Vignesh. Good evening, everybody.
Good evening, sir.
I was told that it is 40th program by Chennai chapter. Correct, Vignesh?
Yes, sir. Correct, sir. 40th program.
Congratulations for conducting so many good programs which are useful for the Foundry fraternity. Thank you very much once again. And this is zero maintenance approach, part 2 by Mr. Sundaresan, sir, Senior Vice President, Operations and Technical, Brakes India Limited. Sir, the whole program was very scientific, systematic approach for the maintenance in Foundry with proper documentation guidance also you have given. Participants, one time it went 95 plus.
Correct.
Fantastic, sir. And the program started right on the time. Yes, elaborate details are given by sir. Regarding air compressor, definitely people don't consider air compressor as a major power consumer, but the way you have given the presentation, definitely it will help Foundrymen to understand how do we attack on the air compressor related issues. Mr. Sundaresan is definitely an encyclopedia of Foundry maintenance, because this many information normally Foundries don't maintain. The way you have maintained the document, the way you have presented the things, you are really passionate on maintenance, sir. Very much thankful to you for a fantastic presentation given in part 1 and part 2 also. Thank you once again, sir. Also, I would like to thank SR Chairman and Office Bearers of SR, IIF Chennai Chapter Office Bearers, SR Council Members, past Chairmen, NC Members, past Presidents of IIF, participants. Thank you one and all once again. Thanks Vignesh for moderating the program. Thank you. Hoping still a lot of bunches of programs are there from Chennai Chapter.
Yes, sir.
Thank you.
Thank you so much. Thank you, Sundaresan, sir.
Thank you all, and thanks for IIF for providing this opportunity to conduct this program on zero breakdown maintenance, and I'm sure that this would enable the Foundry team to work onto this. As I said again, the skill is more important, and getting expertise is all the more important. With this knowledge, this should be a stepping stone. People should try to practice at their own foundries, and definitely there could be wherever there could be an obstacles, they can definitely get away with practicing these methodologies. I'm sure that it would definitely yield a very good result, because uptime of the equipment would definitely improve the uptime of the entire line, which in turn you would see improvement on the productivity, on the quality and other fronts also. So I want every one of you who are very sincere enough to take this up and deploy across your own foundries, and then see the benefit for yourself. Okay, make Foundry clean. Please do join us with the myth of breaking Foundry being a 3D industry, make Foundry also in line with a machine shop. And thank you all once again. Thank you.
Thank you so much, sir. Thank you, sir. Thank you very much.
Bye, Vinesh.